from your lunch. I hope you had a really nice break and had a couple of refreshments. Maybe got a bit of sunshine, a bit of vitamin D during the break. We've got a busy afternoon. We've got a panel discussion coming up, and then we've got two keynote speakers, and then we're going to dive into another panel session before we conclude today. So our next topic for discussion is going to be all about optimising business models for offshore wind projects here in Australia. And I'm delighted to be introducing the moderator for our next session. Her name is Vanya Kumar, and she's the Executive Director, Commercial and Investment Attraction at the Department of Environment, Land, Water and Planning here with the Victorian Government. Vanya is an experienced executive director with expertise in commercial transaction, infrastructure development and project management. She's a lawyer by training. You won't hold anything against you there, Vanya, but she also brings strong commercial negotiation, government, stakeholder management and policy experience to her role. She's worked across a range of industries, including energy and utilities, banking and finance, construction, oil and gas and transport here in Australia and, of course, overseas. Welcome, Vanya, to the stage, and look forward to the discussion with your panellists.
Can I invite all the panellists to come up too? Ma'am? I know we've got a few panellists who are joining us virtually. Right. Hello, panellists. Okay, I might just stand here so I can. If I stand here, because I need to be able to see the remote panellists as well. All right, good afternoon all. Thank you, Andrea and the organisers of the Australian Wind Energy Conference for having me back today. I would like to welcome you all to this panel discussion on offshore wind and business models. Before we kick this session off, I would like to start by acknowledging the traditional owners of the lands on which we are all meeting, and I pay my respects to their elders past, present and emerging, and the elders of any other communities who may be here with us today. So as I'm sure you have all discussed over the last 2 days, Victoria is going through a major energy transition, and we are well on the pathway towards a net zero emissions economy by 2050. This endeavour will require us to identify and use new and innovative technologies to their best potential. In today's panel discussion, we aim to explore offshore wind technology in the Australian context, and we will unpack aspects of the business model in supporting our goals for the decarbonisation of the electricity sector. We have an amazing lineup of expert panellists here today who will step us through the opportunities and the challenges associated with developing the offshore wind industry in Australia. Because we do have a very large and very expert panel, I might not be able to direct every question to every single panellist, but I'll try and direct my questions in a meaningful, and the audience's questions in a meaningful way. So for this afternoon's session, I will get the ball rolling with one question, but before I do, I might ask each of the panelists just to take a minute to introduce yourselves. And let's start with one of our virtual panelists. So Rebecca, would you like to start us off?
Thanks very much. Hi, I'm Rebecca Hewlett. I'm the Global Renewables and Environment Director at Exodus. I'm in Edinburgh today, although I am originally from Victoria. I'm responsible for Exodus's international renewables efforts. I think so. We are an energy consulting firm. We have a lot of experience in Scotland. That's where our home base is, and a fair bit of new experience actually on the east coast of America and now into Japan as well. So hoping to be able to contribute to the discussion. Thanks.
Thank you, Rebecca. So for one of the panellists who's with us today, Casper, you need no introduction. I believe you did the keynote speech this morning, but if you'd like to take a moment.
I can make a short version if there was anyone that didn't hear it. So yes, I'm Casper. My last name is Thorhauge. That can be hard to pronounce. I'm the CEO of Start South, which is the first offshore wind farm being developed here in Australia. And I think just really acknowledging the tremendous moment it is to sit here in a panel on offshore wind and discussing offshore wind on the Australian Wind Energy Conference. That's a pretty big milestone for us to achieve. Been here 2.5 years since I came from Denmark, and that's been a very exciting journey, which is definitely showing a lot of progress, both with the partnership we are looking forward to entering with the Victorian government, which was announced 2 weeks ago, and also the bill going to Parliament and now being enacted and enabling us to continue developing and go for construction and operation. So very exciting times.
Thank you. I might go back to one of our virtual panelists. Taraz, would you like to introduce yourself?
Sure. Thank you, Vanya. My name is Taraz Sabah from GHC. I'm based in Brisbane. I am service line leader for power generation across Asia Pacific. I have been involved with renewables and wind farms and other forms of beach energy projects for the last 30 years. And I'm delighted to be part of this panel and looking forward to the conversation. Thank you.
Thank you, Taraz. And I might go to Nick Sankey now, who has very graciously stepped in at the last moment. So Nick.
Thanks very much, Tanya. My name's Nick. I'm the country manager for Blue Float Energy in Australia. Blue Float is a European-based specialist offshore wind developer. Is backed by 547 Energy out of the US. So Blue Float are currently assessing sites and business opportunities for offshore floating and fixed projects in Australia. Prior to Blue Float, I was involved in developing a large-scale solar farm up in Queensland, and also worked for many years as a financier to renewable energy projects.
Great, thank you. Patrick, we might go to you.
Thanks, Vanya. Hi, everybody. My name is Patrick Gore. I'm an associate principal at Arup, and I'm our Australasian commercial lead for our energy business. I'm ordinarily located in Melbourne, but at this point in time, currently in country Victoria.
Thanks, Patrick. And last but not least, by any stretch of the imagination, Jacques.
Yeah, good afternoon. My name is Jacques Lemons. I work with WSP Golder. WSP Golder is a big company. I believe it's even the biggest engineering company, environmental engineering company. My background is in marine science, and I've been working around Australia for about 35 years, from Kimberley to WA to Queensland. I worked a couple of years at Great Barrier Reef, and for the last 4 years, I've been working in Bass Strait. My main background in the last 20 years has been in oil and gas environmental approvals. And just recently, I joined WSP, joining the team helping out with the offshore wind developments.
Thank you all. Now I'm going to start off with one question, which I'm going to ask all of our panelists. It's a bit of a provocation, but please feel free, if any of the audience has any questions, to put your hand up, and Charlie, someone will go to them. Fantastic. So this is a question that exercises the mind of me and my team, I know. Considering Australia's remote location and distance to established offshore wind industries, how does Australia manage the challenge of developing its offshore wind industry? And Jacques, because you got to go last time, I'm going to go to you first.
Okay, well, this is of course a $1 billion question. Luckily, we've got some people from Europe who've been bringing some expertise across to Australia. At least we can lean on that 10 plus years of experience in Europe with offshore wind. Obviously in Australia, our biggest challenges are finding local talent that can provide that sort of expertise. If we look at the main stumbling blocks around offshore wind, you deal with marine environment, shipping, fishing, marine national parks, potentially some oil spill issues, major engineering challenges of building in the very challenging marine conditions. And if you put all that together, really the best analogy we can find in Australia is from offshore oil and gas. As you probably know, in Bass Strait, we've had an offshore oil and gas industry for about 50 years. With the industry has been dealing with these sorts of challenges for the best part of that time. So I think we can learn a lot from that industry, not just from the engineering perspective, but as it happens with the announcement of the offshore electricity infrastructure bill. We've just been told that NOPSEMA is going to be the regulator for offshore wind. And again, NOPSEMA has been dealing with the offshore oil and gas industry since its inception, about 10 years. We're still waiting to see the detail, but at first sight, it looks like there's a lot of analogies in the environmental and safety approvals regime for oil and gas and offshore wind.
Thank you. Patrick, we might go to you for that question as the next respondent.
Thanks, Vanya. Look, I think probably to Jacques' comment about the skills, that any real development for long-term sustainable industry needs to consider the skills. And this is something that's apparent in all of our emerging energy markets. But to make this sustainable, we have to train, redeploy or retrain, develop and make these skills locally and make them competitive on a global scale in order to service the industry. And that's not just in the design and the development and the construction, but the ongoing maintenance, the outages, the facilities, the onshore and offshore facilities, the connections, all these things. We need to have these skills kind of developed here. Because when we talk about the size of some of these developments in the multi-gigawatt scale, there is enough activity there to support a full industry. So we want to try and, I think, avoid doing what we do with some of the oil and gas industry, particularly in the northern parts of Australia, where they're shipping people in for outages. And if we can develop those skills locally and have them moving around Australia, then we can effectively mitigate that.
Thank you. Casper.
Thank you. I think it's both an opportunity and a challenge, given that we have developed Start This Out and tend to be optimistic and believe that things will happen. And I think there's a lot of companies in Australia already well known to me, being explored to the global supply chain. A lot of companies in Perth who's serving the oil and gas, but also all over Australia. And they have been so kind of reaching out to us and following the progress that we are making, and we look forward to entering that dialogue with them. And myself, I come from the power sector, so I used to I'm an engineer specialized in power plants with coal and biomass and gas. And there's a lot of skills people in Gippsland where we have our project that also know this, and there's a lot of skilled people within oil and gas. So I don't really see it as a challenge so much to getting the skilled people. We know we need to work with the different educational centers to tailor those people to work in our industry. But the talent is there, and we're pretty comfortable. And then you say the distance to other markets. The lucky thing you can say is that the APAC, so the Asian country, are really booming ahead in this industry right now, which brings a lot of the technology closer. Then the fact that we are sitting here discussing that we want to have an industry, of course, attract the travel distance becomes something as an advantage instead of a disadvantage. If you look at what can you build in Australia. So if there's a strong political signal that a sector is here with clear strategy and policy settings, there will also be an increased interest in reducing that transportation cost.
Thank you. I might go to Rebecca. Rebecca, what would your views be?
Thanks, Vanya. I think this is really relevant to what we're seeing both in Scotland and on the east coast of America. So Exodus has been involved with some cluster builder initiatives, and they're really an opportunity to bring together various supply chain members and partners to actually start looking at what the opportunities are regionally and starting to collaborate, drive a bit of competitiveness and actually get clarity for the developers and the tier ones to actually see what is available locally. And I think driving that supply chain gives an opportunity to amalgamate and have a regional approach, which I think makes the remote location less of an issue if people are working together and seeing an opportunity to collaborate. And I guess what we've seen in our work over on the East Coast with Hampton Roads down in Virginia, that the governors of Virginia, North Carolina and Maryland have seen an opportunity to have an MOU for supply chain for the offshore wind industry. And that is a pretty strong sort of opportunity there to see and how that can be architected to actually collaborate and make the best use of a regional resource. So instead of competing against each other, these three states have actually agreed to look at opportunities to entice fabrication and various sort of tier one OEMs into the region. So I think the collaboration, being able to use that cluster builder approach that Scotland has been sort of championing and also looking at ways of working together regionally is going to make a huge difference in this case.
Thank you. Taraz.
Yeah, a lot of good points mentioned by my colleagues. A couple of points from my perspective. I guess the challenge of Australia being remote, when it's looked at in the context of the global will and desire towards net zero by 2050 and the transition, the energy transition we are in, to me that challenge becomes quite small, because we are now, it's very different to other times of the past. The global will to push towards 2050 and hence renewables as a major tool. And when it comes to offshore wind, as we know, it has to be a big part of it. It really brings a lot of impetus into, and Australia becomes an important player. Also, the second point I was just mentioned, which Casper mentioned also, that being close to Asia Pacific, we know that offshore wind at the moment is centered around Europe, but all the forecasts, in fact, already shifting towards Asia Pacific. We're already been a beneficiary of being close to the Asia Pacific, and our onshore wind has benefited a lot, and offshore won't be any different. And I think that we're very unique, and I guess very fortunate to be that close to that market and the technologies. And when Korean and Japanese start getting to the offshore floating in particular, it will bring a lot of benefit to Australia, and that the magnitude of the challenge, it will become much smaller, in my opinion, compared to other countries for us.
Thank you. And Nick,
Sure, a lot of
do you
good
want me
points.
to repeat the question?
No, that's okay. I can remember.
Okay.
I mean, a lot of good points have been raised, and to my mind, it's about scale that will offset some of the challenges of being remote. So, I guess Australia, in the past, for many industries, as we're trying to scale up, being remote is hard to establish industries in Australia, but we've got we've seen the scaling up in Europe and now Asia of offshore wind, and so I think Australia's going to hit the ground a lot further in front of those geographic regions. And I think for once, Australia will have the benefit of having an industry at quite serious scale very early on. We've seen we're talking gigawatts and gigawatts that just can't be achieved through other renewable sources that need to be deployed in Australia. So I think it's the ability to start at a relatively large scale that will help offset some of those remote challenges.
And what do you think, Nick, is the scale of the opportunity here in Victoria, or in Victoria and then more broadly in Australia?
Yeah, sure. Well, I think Casper put up in his presentation a number of the sites. Now, of course, all these sites at the moment are just proposals and lines drawn on maps. But when you look at the coal fleet in Latrobe and Hunter Valleys and the retirement over the next 10 to 15 years, you've got 10, 20 gigawatts at least And when you look at the capacity factors of renewable, even more that has to be deployed through replacement generation in Australia. So I think, particularly off the New South Wales, Victoria, South Australia, and Tasmanian coast, there's a massive opportunity for scale just for pure replacement. And then on top of that, if you add in the push for new industries for green steel, for green hydrogen, you've got the opportunity for Australia to be exporting new industries from renewable energy generation.
Thank you. Caspar, I might go to you and building on that question, what are proponents going to find here when they come here? As the first, as you've said, what are people going to find when they come to Victoria in particular? What did you find?
What we found, we came pretty early, and the project was founded by 3 Australians, and were pretty visionary. And then in 17, SIP bought in. So what did we find? I think we approached it from a very macro point of view, is that if you look at Australia, it has an aging power generation fleet. So something needs to be decided of what is going to be the future for power generation. And we believe offshore wind has a lot of merit to be considered in those technology choices that has to be made for the future. And that has been our belief and our view when we entered the market. Then I think we have been quite welcomed as a new proponent. An example is we received our exploration license from the federal government to explore out in the Commonwealth water. We have also always had good dialogue with the Victorian government, who has been very interested in understanding the industry and learn more about it. And as you can see, it has materialized into now a formalized partnership of accelerating development in our projects and 2 other offshore wind farms. So I think generally quite welcoming. If a new proponent came here, I think it would be very different. It's a lot more mature market. There's a lot more clarity with the new legislation in place, and hopefully also some signs coming out of the offshore wind sector strategy being announced maybe later this year.
Thank you. Rebecca, I might go to you for the next question, and just building on that question. The US suddenly, well, I'm sure it isn't sudden, we know they've been working on this for 10 years, but just seems to have exploded onto the offshore market in the last little while. What triggered this, and how can we learn from that?
So I think there was a slow start, and I think under the Trump administration, the process of getting vineyard wind over the first hurdle was really the thing that people watched very closely, and there was a lot of focus on seeing if that would start. And then also the change in the administration then started a more federal approach. I think it was very state driven to start with, and I guess this is again sort of building on the theme of actually being able to work together across state boundaries and having federal push towards bringing together regions. And I think we've seen some pretty major moments of clarity recently. I think the Commonwealth of Massachusetts recently removed the price cap for the new wind farms coming online, which means that each project doesn't need to be necessarily cheaper than the previous project. So that means that the developers have a real opportunity to work with the local governments and the federal governments to incorporate things like interesting solutions for energy storage, improved reliability, but more importantly, that greater economic local content. And I think that is where America, and particularly the East Coast, is working through what exactly the US wants out of offshore wind. Is it the cheapest possible, lowest cost, lowest LCOE, or is it a blend of reliability and local content and opportunities for a just transition that brings more people along, that has more sort of equity around the supply chain, that gives the workforce opportunities for diversity, equity and inclusion that all the states, particularly in that area, are after. So I think it's actually widening out what the opportunity means and making some strategic decisions about what what the benefits are most important to each jurisdiction is. And I think that is a real opportunity now in Victoria in particular to work out what the priorities are for the opportunities around offshore wind.
Interesting. Thank you. So, Patrick, I'm going to start with you. But what the discussion that we've had just now and the discussion we've had over the course of the day, what do you see as the commercial parameters of the business model for offshore wind? And I know that's a really big question. Yeah. Just pick the things you want to talk about. But
I mean, can I use the next 30 minutes up or just on that?
Just pick a couple. Just pick a couple of sort of themes that you see emerging.
Yeah, no, thanks. I think you know, just to Jacques' point earlier on about the latest Commonwealth changes has really mitigated quite a bit of the risk in the uncertainty in the environmental approval space, because we're working on offshore wind farms across WA, South Australia, Victoria, and New South Wales, and having, you know, some of the uncertainties, the differences in that approvals program and what it's going to look like. I think the route to market certainty is another piece that we're still, you know, to Rebecca's point, we take a very sort of siloed state-by-state approach to how that's going to look. And if we looked at, say, the model of what's happening in the UK with the, you know, contracts for difference and giving developers, you know, confidence and certainty in what that offtake agreement looks like, may be helping with financing. I think the last one, I guess, you know, that's probably more in the development, in the financing part of things. You know, earlier today we heard about making Australia attractive as an investment market. You know, some of the grid connection risk that surrounds some of these developments is certainly something that needs to be considered. And we've talked today, just recently, what happens in the construction phase, and what does the supply chain actually look like? Where, you know, emerging technologies require significant investment to establish, modify, develop these supply chains, and they're going to last for a long time. We spoke about the labour market, and I commend Casper's optimism, and in the face of other emerging markets, I also wait to see how this is going to develop, particularly when we look at things like hydrogen, and probably from a very specific type of thing that, from my experience internationally, is just, you know, having consistency over the contracting structure and type. So Australia has a penchant for bespoke contracts in construction for absolutely everything. If we could get to a position where we were having, you know, whether it's a FIDIC-based contract or an NEC-based contract to kind of develop these projects, that will give certainty not only to our developers, but right the way through the supply chain, from the tier one contractors all the way down to the small suppliers and local manufacturers and that sort of thing. So yeah, in a nutshell, that's probably my key points, Vanya.
No, thank you for that, Patrick. And Taraz and Jacques, I'm about to ask you a very similar question, so I'll give you a moment. But does anyone in the audience have a question? We've got a question here.
Thanks. Matt O'Connor, Gilbert and Tobin, lawyers. Sorry, so I'll just pick up that point there about the bespoke contracts. They're always better. But my serious question is, all things considered, so question to Casper and to Nick, and then anyone else who'd like to comment. All things considered, is being a first mover an advantage or a disadvantage in this space?
I can give it a go. It's a very good question, and the future will decide. But I think it's an advantage. Of course, it comes with significant amount of risk. And why should you take the risk? That is also due to purpose. You know, you have a belief that what you do is right, and that it will make sense in the end, because you can see in the big picture it does make sense. You take that risk and it brings you into a position of advantage, but you didn't get it for free, that's for sure.
Yeah, and I guess I'll say only with the benefit of hindsight, we know the answer to that question. But I guess, yeah, our view is that being an early mover is an advantage I think obviously the site selection is critical, and that can be a real benefit. But then you offset that against potential, potential technology changes, cost efficiencies as the industry gets developed, which will potentially offset the benefits of site selection. But we think being in early and selecting the best sites will be an advantage.
Thank you. I think we had another question in the audience. Did we have another question in the audience? No. All right, I shall keep going, but please do think about your questions. So, Taraz, with your technical background, what are the elements of the business model that we should definitely take a look at in Australia?
Thank you, Anya. I guess when we look at the learnings of other countries, almost 20 years ago this time, this year, sorry, the first offshore wind farm went up. In Denmark, it was only 11 turbines, 5 megawatts, and now we are sitting at 33,000 megawatts, almost 6,500 times more. So the experience curve is quite rich when we are sitting here, and we need to use that for our financial to make sure we use the lessons learned. I guess the collaboration is the big term that comes to my mind, that we need to collaborate with other regions. They have built wind farms, offshore wind farms. When it comes to the technology, we are quite fortunate that our onshore industry is quite mature, and we have picked up a lot of learnings from onshore market. That is, most of them, I guess, from waste up, these turbines are pretty much similar. So that could be translated into offshore projects. Of course, people like Casper, they have gone through a tremendous learning curve about those challenges of the offshore. So it's a totally different beast. But in terms of helping the financial model, the business model we are looking at for offshore, we do need to bring in the learnings we have got from onshore and from offshore other markets that we have, and obviously benefit from the technological advancements that has come to offshore market, and especially in the last 10 years, and we have seen tremendous growth in offshore. If you look at most of the 2 to 4 megawatt machines that we've got installed onshore, they are pretty much were the platform designed for offshore back in 20 years ago, and the uptake of the offshore for a number of reasons was quite slow. So the OEMs started marketing them for onshore, and then those turbines are been up and running for a long time. So a number of learnings from those we can apply to offshore, and of course the way we the contracting, the O&M contracts, and that we have been doing in onshore projects, bring a lot of benefit to projects in offshore.
Thank you. And Jacques?
Yeah, I've got a slightly different angle. I mean, and I think we've discussed it sort of in the corridors already. It's great to see the offshore infrastructure, electricity infrastructure bill being approved, but of course, that's not the end, that's the beginning. There's a lot of work to be done. There's a lot of clarity that is required before we can really start moving ahead. Yes, we've got the NOPSEMA model for oil and gas, but there's still a lot of questions around that. We filled in. I know quite a few people who come from the oil and gas background are also quite nervous about the approvals process, which can be quite onerous. It's very, very labor intensive. Some of these documents are in the order of 2,000 pages and could take a year or more to prepare. Talking about first cap of the rank, yes, there's lots of advantages to that, but of course, there's also some risks in that it sets the scene for the rest of the industry. So I think if the first cap of the rank promises to deliver too much in terms of environmental and safety assessments, that really locks the remaining industry into a very long process. And you guys have been going for 5 years. I hope that the next offshore farm doesn't have to spend the same time to get to this point. Yeah. And then the last point that I probably should make is, I mean, the bill talks about a 7-year exploration or feasibility license. I'm sure that's going to be a very competitive process. And although we've got a lot of ocean, a lot of it is too deep for fixed structures. So there will be a lot of people looking very closely at floating infrastructure. I think fixed structures, you can probably get to about 50, maybe 80 meters water depth. Within about 20 nautical miles from the coast of Australia, we are in over 100 meters, and very quickly we end up in about 4 kilometers, 5 kilometers water depth. So we really need to go for floating structures, and that's got a lot of uncertainty still. Yeah.
We're going to get to fixed and floating structures. It's on my list. But just before we do, I want to just close out the point around manufacturing. And I might direct this question to Casper and to Nick. Europe has done manufacturing so well in this sector. I think the last statistic I read was that there were 77,000 people in the EU employed in the offshore wind industry. And by 2030, that number is expected to increase to 200,000. How on earth do we do that in Australia?
I think it's pretty interesting you asked that, because that also comes with a very significant target of how much offshore wind will be needed, and that would be a good news. No, a lot of talent is required and a lot of training is required, but it's also important to acknowledge that the European Union didn't do it in a few years, but it's happened over decades. It's happened over with strong policy setting and drive of how to get there, which has enabled the industry to follow suit and transition workers from one industry to another. I'm not underplaying that challenge, but most people will be excited about that journey. That's our experience. I've been part of developing the Taiwan market as well. Workers are keen on this new industry and is excited. The same we see in Europe when we go out there. And when we go around in our community, especially around Gippsland, they are daily asking, is there any opportunities? When do you think this becomes real? People are willing to onboard that journey and learn what is required.
I also say that I think Australia has quite a high kind of per capita percentage of people involved in the fossil fuel industry here. Yeah. So we're seeing a massive redeployment of people in the Latrobe Valleys, in the Hunter Valleys, and related industries that have been dependent on coal and thermal power generation. That there's a huge opportunity to retrain and to have training programs to bring up the younger generations coming up who would have traditionally gone into the thermal generation industry, but they'll now be coming up through the renewable energy market. So I think when we can combine offshore experiences, import some expertise, but then train and redeploy other skills within Australia, I think there's enough capacity to transition.
Okay, so Rebecca, what is the US doing in this space?
I think in workforce readiness, do you mean, Vanya?
I mean, in terms of manufacturing and making, growing the supply chains locally.
Yes, I think that there's a few things that are happening there. So, I mean, when we look at, and we've done various supply chain studies for various states on the east, and it's the two hurdles that are identified repeatedly are this delay or uncertainty around permitting, which we've discussed, and many panelists have sort of been able to bring together those themes. But then there's this reliable local or regional supply chain. And I think the things that are the areas to work on is this: the developers and the OEMs really need a robust database that's actually easily understood and a proper pre-qual of local suppliers. And I think work being done by organisations like the Massachusetts Clean Energy Centre or various bodies that actually connect the developers and the manufacturers with the local supply chain in a way that's meaningful. And this can be right through from vendor events, interviews, being able to actually pull together meaningful databases to allow people to understand where the opportunities are. And then I think there's an opportunity there to then start working together at state and federal levels, both in the UK is similar with these cluster builders, is to look at ways of enticing manufacturing facilities to be established. And then it's the process of this workforce readiness that needs to happen. And I think, again, you know, we see, you know, Exodus headquarters is in Aberdeen. You know, we were originally an oil and gas focused company. And I think the way that we've been working on this is to look at bringing on lots of people from lots of different diverse backgrounds and being able to provide training and experience to be able to service the offshore wind industry in Scotland, but also in the US. So I think it's those things adding together, but also being able, so it's that accessibility of what is available easily. So there is a smooth information flow between what the local supply chain can offer and what the developers and OEMs need. And that facilitation, like the impact of that can be very high.
Thank you. Just before I go on to my next question, are there any questions in the audience? Got a question just here.
Australia's onshore wind industry in the past has been a bit stop-start for various reasons. Obviously, one big thing for the industry has been grid, and a strength at the moment for the first incumbents in offshore wind in Australia. So you can, plumb into Latrobe Valley, Hunter region, etc. Is there any risk after the first incumbents come in, connecting to those kind of low-hanging fruits, that there might be a bit more of a lull after a few years, the first few projects got off the ground? Therefore, that continuity that you really want to have with a new industry isn't so much there, and it's not as smooth as we would like it to be. Does more work need to be done on the grid now, even though there's low-hanging fruit already? Do we need to start thinking about 5-10 years after Star of the South and other projects got off the ground to make sure that that's a smooth long-term future for offshore wind?
I think definitely that. I think one thing that we're going to be proposing and pushing for is shared infrastructure, and I think particularly in terms of onshore transmission lines, getting to connection points, and getting from offshore onto the onshore. I think if there's a coordinated approach within the industry and some longer term planning to build the capacity that it can accommodate multiple sites, I think it'd be a real shame from an investor, a stakeholder, environment, everyone's view, if we have competing transmission lines going basically to similar connection points. So I think just saying here is what we should have is planning with government, I think, to have a transmission pathway into connection and to be providing for a longer term connection over a number of sites in the key areas that many developers are looking at the moment.
Thank you. Does anyone else want to answer that question?
I can add a little bit. For the first many years, you can say there will also be an exit of power generation in the NIMP. So it's not an immediate problem. For example, if you look at Latrobe Valley, is arguably the strongest connection point in the whole system. Which is also one of the reasons why the founders originally planned, for example, Star of the South in this region. And over time, you will see Yallourn exit, and you will see Loy Yang A and B also exit, which frees up capacity. But I'm strongly encouraged by, for example, the EMU having 4 zones of each 10 gigawatts being explored, with 2 in New South Wales, 1 in Victoria, 1 in Tasmania. So it's positive they're looking into to the longer view of how to accommodate this.
Now I might just check what my time is like, because I know we started a little bit late. Oh, right. Okay. Well, I was going to ask about fixed and floating platforms, but I'm going to whip around my panel because I cannot resist doing this. And I'm just going to ask each of you, what are the 2 things that we in Victoria need to get right to optimize the business model for offshore wind developments here? What are the 2 critical things? And I'm going to take notes too. So I might start with Taraz.
I guess one thing which is very technical, but it's a common sense, is about getting the actual how much energy is going to come out of those projects, and what we commonly refer to as capacity factors. And the capacity factor is quite sometimes it's become misleading, because what we see in the outlook report, they refer to 60 to 70% capacity factors for offshore projects. Whereas once you include all your losses, wake losses, electrical and grid connections, the availability and stuff, the number isn't that high. And the studies we have done for the Victorian context, that the realistic capacity factors at the metering point would be around mid-50s or a little bit higher, or a little bit, so that having capacity factors of even so the technology is quite advanced, and we're getting bigger turbines, bigger rotors. Assuming these to me unrealistic numbers of 60% or thereabout in business model, that becomes it's quite dangerous in my opinion. So that's one thing that we need to do. And in terms of technology, second thing is about the logistics of installing these turbines. The port facilities, the craneage, the installation vessels. That's an area we really need to focus on, and something that I'm sure Casper and his team have been working on it. That's an area that it has to be collaboration across the industry. It can't be just left to one OEM or one project to deal with it. It has to be a unified, coordinated. And I know sometimes it's very difficult when you think of the onshore projects. Each project competes against these two.
Thank you. I might go to Patrick. 2 things
Thanks, Tanya.
we should do. Yeah.
Look, I think offtake certainty. So, building on the VRET process that you champion, Vanya, going forward with a really strong contract for difference to provide developers with a strong route to market is one of the key development risks that needs to be mitigated, especially with an emerging technology. Offshore wind will be more expensive than other generation types for quite some time until you get the price down. So government subsidization is required. And the other thing for me is supply chain risk. Whether that's in manufacturing, security of, as Tara said, vessel procurement and that sort of thing, and also just getting the right skills. We've just seen another couple of gigawatts announced recently in Victoria, so that's a lot of people required to build these projects.
Thank you.
Thanks.
Jacques.
Yeah, my concerns or my worries are more around the regulatory regime. We talked about it before. Potentially there will be 3 or 4 different pieces of legislation that the offshore wind farms need to deal with. Obviously, the EES process in Victoria or similar processes in other states. We've got the EPBC Act still. And then, of course, NOPSEMA will have requirements for an EMP or whatever is going to be called. So there is a clear risk for duplication. And I know that's something that Star of the South have already been dealing with an EAS/EIA. But yeah, coming from the oil and gas industry, where we had this tug of war between state and Commonwealth legislation, that's a concern. The other concern, coming back to the question that came from the audience, is around long-term job security. Oil and gas has got the habit of kicking off a big project, scrambling to find people. The project continues for 5 years or so, and at the end of the 5 years, those people are basically out of work, and the next project comes along, and they have to go through the same process again of finding qualified people.
Okay. Thank you, Rebecca.
Thanks. So so we often talk about when we're trying to look at the development, like early stage development, we really need to make sure each project is buildable, bankable, and consentable is the term that we use in the UK. And that's really to do with the permitting regime. But I think the bankable and consentable aspects of what we're talking about are the two things to get right now. So I think what we're seeing in Scotland right now is trying to apply the things we learned through getting the consenting regimes right with a lot of fixed wind projects to try and make sure that we don't go backwards to try and move into the floating space. So I think get a centre of excellence organised, get an environmental interactions roadmap sorted immediately. So you've got something that actually cuts down the time it takes to get things consented and actually drives a bit of collaboration. So I think that focus on actually reducing the time it takes and increasing the certainty around permits is crucial. I think the other thing around about projects being bankable, I think the government, I'm afraid to sort of be so direct, really needs to be clear on what the priority is here. Does the Victorian government or the Australian government want the cheapest levelised cost of energy or the best opportunity for local content and environmental justice? There has to be a blend, but de-risking projects isn't free. And so there is a balance to be struck there. And I think clarity about what the vision is will help developers understand where their priorities are and where their opportunities are.
Thank you. Nick.
Yeah, I think I already mentioned shared transmission onshore. So I think a really an efficient approach to common infrastructure and transmission, and I think efficient licensing and regulation and permitting.
Okay, and Casper, I might let you have the last word.
Thank you. A lot of good words have been said, so there'll be a little bit of a repetition in it. I think the two things Victoria can do is work with the legislation. It is a new thing for the industry it's the same in the US where we also have our projects, but you can say we need here to find a way to get both a Commonwealth approval and a state approval. And that goes for our environmental work. And we are proud of the work we have been doing with DELP and with AuWE. And it's been really good to learn and make a strategy. And everyone has signed up for how we want to do it. But we also need to commit to maybe a lessons learned at one point in time, for the next projects to come. How do we streamline that? But now the bill coming in, DICER and OPSEMA, and all stakeholders will be part of developing the regulatory framework that we also as a Victoria needs to be part of ensuring that this makes sense from a state point of view. And I think my second point, and I have repeated a little bit before, an example, it's outlook. What is the expectation? And I think Victoria here is already doing the right thing. An offshore sector strategy has been communicated last year. Hard work is going into it. There's a commitment to announcement and sharing what is inside that one. And that will help the industry to be convinced that the market is coming. One example is that 2 years ago, we saw an opening in the market for attractive prices of doing our geotechnical work, and we tested it, and it was okay, but we decided not to pursue with it. At that time, I think we got 3 competitors for that. But now we bid it out again after we have ended the partnership, a strong commitment from the government, and we see a substantial amount of people wanting to be part of such a tender. So the supply chain is already noticing it. So the more long-term perspective that can be shown, the easier for us as a developer will be to fit into what Victoria needs.
All right. Thank you so much, everyone. I did have another page of questions, but I'll stop there because I'm holding you back from your coffee. I might just quickly summarise. Offshore wind is both an opportunity and a challenge. We need to put some vision down. We can see what other governments are doing. The locus of control for offshore wind is moving from Europe, maybe towards Asia. And for Australia, that represents a really great opportunity to maybe seize the moment. I'll stop there because I'm way over time, but can you please thank the panelists in the usual way?
And thank you very much, Vanya.
Lost voice.
Okay, I think that's us. Thank you very
I
much,
think
everyone.
they have uploaded
Great.
us. Thanks, guys. Nice meeting you.
Thanks, guys.
Yeah, nice to meet you
Bye.
too. I'll let you go back
Yeah.
to bed, Rebecca.
Yeah, I think that
See
is
you later,
definitely
everybody.
the plan. Bye-bye.
See you later,
Good night.
guys. Bye-bye.
You guys. Thanks, Patrick. Cheers.
all the dramas. So I'll run you through a bit of that. And I've named the presentation a new philosophy because I guess when we began, the supply chain for repair, spares, maintenance, it was very much Europe-based. If there's a problem with your gearbox, your generator, it all got packed up and shipped overseas. And that's still happening in quite a large percentage of cases. So we all purport to be in the green energy business, but in the back end of it, there's still a lot of carbon burnt, a lot of things done in other countries. So let's take a look at that. How do I change the slides on this? Is this my clicker up here? Okay. So just a quick brief. So I'm just going to show you Movenus at a glance at the company. Not a shameless plug, but just a bit of an outline of competence and why we are where we are. Gearbox overhaul, its impacts to operations and the environment. Condition management system benefits, which I'll get more into our system. The evolutions of field service out at the wind farms, and just a little, I guess, talking point with the rush to market. So we'll move on here. So Movenus has been making turbine gearboxes almost since, well, they began commercially. So we've got about 40 years of experience of production and service. We're headquartered in Finland. We've got approximately 550 employees. As I said, we've been there since 1980 and quite a large install base all around the globe. We do a lot of multi-brands, so not just our own gearboxes. We do a lot of other manufacturers as well. And we pioneer a lot of up-tower repair works. I guess our capabilities is quite broad. We supply a lot of new gearboxes to wind turbine OEMs, Vestas, GE, the Winds, the list goes on. We do a lot of pooling for customers where we keep their gearboxes and rotate them out. Workshop repairs globally, field service repairs globally, spare parts and monitoring as well. This is our global footprint to date. So we're across 5 continents, 13 countries. We do a lot of other brands, as I said, and we also exchange a lot of field service labour around the world, although the last 2 years that's been a bit prohibitive. Just a little bit on our local operation. We just opened a new service centre in Dandenong here in Victoria, which we feel is an optimum location at the moment. We've got about 1,300 squares there. A lot of specialist tooling and jigs. We base our field service out of that facility as well, a lot of inventory. And the majority of our guys are here too. We do have a few other in remote states as well. So that's the local fit out. I don't know if this will, am I able to play this from here? I don't know if I can do it from here. It's a video. It's all right if I can skip through it. It's probably a bit too tough. That's all right. That's all right. We'll move on from there. So our gearbox overhauls. So when I talk about a new philosophy, there's still probably 70% of gearboxes coming out of wind turbines that are making their way back to repair loops and repair shops back in Europe, which costs a lot. It costs a lot of time. It costs a lot of carbon. The shipping industry at the moment is completely clogged. We've got probably double lead times going back and forth to Europe with some major components lately. These big beasts, they burn bunker fuel all day long, and they contribute quite a lot of cost to the environment out there. So I think as a green energy industry, this has to change. Particularly with the numbers that we're getting thrown out now with, you know, doubling, tripling all of our wind turbine production. So it's something that needs to be managed and it's something that needs to be addressed. So big point there. I'll expand on that a little bit into these numbers. So if you look at a side-by-side cost, say of a 3 megawatt gearbox that you need to overhaul out of your turbine, the average cost of it, if you're looking at option one and you're sending it back to Europe, it's going to cost you about 90 grand to get it there and back by the time it's said and done. Local transport on cost, craneage, getting it out, the overhaul back there, getting it home, about $375,000. So it's not pocket change. And the turn time to do that is about a year lately. So if you can think about your planning with your wind farm and you can wave goodbye to your gearbox for a year, I don't think there's many many wind farms out there that can do that. If you look locally, we can probably save about 100,000. We can cut the lead time down vastly, and our CO2 emissions are drastically reduced as well. And it's not just that. I mean, that's the quantitative part of it, but the qualitative part of it, if you look at local, we've obviously got all the economic benefits from it. We've got our support infrastructure, we've got local machining, we've got local bearing sales, even though they're not produced here, but it still contributes. A lot of local fitters, there's been mention of, I think the last presenter mass deployment of other trades and services from mining, which is going to be a tough one, but we need more training on that. We've got project jobs associated with it. Our local tooling, I know we fuel a lot of local tooling shops around the Dandenong area because of our new location already, and apprenticeship schemes as well, which are really important. I think this country's given way too many apprenticeship schemes away. There's many companies that have done it. So we need to get that back into play as best we can. And hopefully, and then I mean, we look at the cost of it financially, and it really adds up. 10 overhauls in a 4-year period, 12-year-old wind farm, the numbers start to really stack up. And with the turbines getting bigger, these numbers are going to get bigger. And I know if I was an asset owner, this would mean a lot to me. So the back end costs of wind farms, as I said, once they're up and running, there's a lot to think about. And this is only a small component of it. So move on from here. So as I mentioned, local jobs, environmental impact, our operational control, we lower risk. And you might ask, why are we doing it overseas? But as the gearboxes get bigger, you know, the demand to load test the gearbox after it's been overhauled is quite high. The risk is high. Craneage getting a box in and out is a lot of money. We don't have the infrastructure in Australia right now to load test these big beasts. It doesn't happen. We can do probably up to 2 meg, and there's a couple of players that can do it. And even on a good day, they're probably only getting a megawatt out of their stand. So that's a massive thing. We need to do something in Australia about that when we're talking about the load and the numbers now. As I said, once they get into the 5, you know, we start running into some big problems. So if you look at the progression just in 10 years, the designs have been changing quite a lot. So if we look at a 2010 gearbox on the left, I don't know if that makes sense to a lot of people, engineers, I'm sure, very quickly. But they've gotten a lot more complicated. Early boxes, we had one set of planetary stage with 3 small planetary gears in it, 2 helical stages in there, and an overall mass of about 20 tons. And then fast forward 10 years, we're doing, you know, 5.7 megawatt boxes, such as the one on the right, and we've got 2 stages of planet gearing. We've got 5 planets in the first, 3 in the back. We're using plain bearings now, integrated journal pins, axial thrust bearings, things that would get used in turbo machinery industry that are creeping into wind turbines. And again, new skills, a lot of people here that have never touched it, even my guys included. You know, with COVID, we haven't been able to get training done. So these things are getting installed, and we're catching up ourselves, even as the OEM. So, you know, this country's been very exposed with its supply chain the past 2 years, and the wind turbine industry is definitely one of them. Our service workshops, when we get into the larger gearboxes, we can't do them here because of the load testing mandate on some of them. So we've got a global workshop network, but again, we're sending things overseas, something we don't like to do. But we do have the capacities to do that over there. And we also upgrade gearboxes too. We find with the constant evolution of things, and wind turbines still being an emerging industry, the gearboxes get out there. They've got design problems and things that need improving along the way. And that's always a challenge because every single year there's another brand new wind turbine on the market. So we're constantly chasing it. This is a solution we develop as well, where we create an overhaul repair loop for customers. It's something that's been done successfully. If we do need to send major components overseas, we try to understand the planning behind it and have everything ready to go. So we've got some immediate response times for them. So yeah, another option we've developed with certain customers. Turbine monitoring. It still probably shocks me that there's a lot of turbines out there that don't have monitoring on them. And with the cost of the asset, it's quite unbelievable. And you have a lot of wind farms that'll take an oil sample maybe once per year. There's a lot can happen in 12 months to a wind turbine. So we monitor ours quite a lot 24/7. We've got a lot of monitoring stations throughout the world that we do this on. And we monitor the entire drivetrain. It's not just vibration analysis. We monitor the oil, we monitor particle count, metal particles within the oil. We monitor the quality of the oil, water content in the oil. So it's a very rounded approach. And the reason we do that is probably coming up on the next one. For anyone that knows anything about wind turbines, there's a planetary stage in the gearbox. So we've got a helical gear train that you can easily place vibration monitors on, but a planetary stage is something rotating within a housing. So you can't place vibration monitors on planet gears. And the planetary gears in the turbine is the most expensive stage of gearing in the turbine. And it's one of the stages that we have few opportunities to fix up in the tower. So we will find when we monitor the turbine with oil, the oil will always release medical particles before we see any vibration coming to the spectrum. So this is how we pick up on planet gears. And if we can detect that, we can normally save a catastrophic failure in the gear unit. And I have an example there. So if you look in real time, on the top graph, we can see our oil particle counter on a gearbox. I think it was on a V80 gearbox in the States, but you can see how the oil particles start to rise and accumulate very quickly, but you can see the vibration on the same time scale just have its little bips every now and then at about 1 millimeter per second, which isn't very alarming. But by the time you get to the very end, that's when the damage is done. So you can see by some numbers there, it's you know, to monitor your turbines properly is going to save you a lot of money in the long run. And to monitor each turbine 24/7 with us, it's not a lot of money. It's about $1,000 per year, so it's relatively small investment. I suppose just looking at some of the gearbox deliveries we've done over the time. So a lot of pieces there, growing and growing, as I mentioned, over 15,000. I think we're well past that these days. But field service. So no, Venice, this is our first response every time. This is the cheapest response. It's the best response. It's the most inexpensive response. This is one of our jobs we're doing in the States, but so we do a lot of up tower gear replacement solutions up there. We customize tooling constantly. We globally train our teams. We do a lot of information sharing across the globe. We have to reduce downtime and lower our costs, constant philosophy, which is hand in hand with field service. Inventory planning, that's massive right now. Lead times are getting longer and longer. We have some bearings for certain field jobs that have a 12-month lead time. So you can imagine a turbine down, you got a 12-month lead time on a bearing. It's not a good situation. So planning your maintenance is a big deal right now. We're manufacturing gearboxes that have a 22-month lead time on certain bearings. And if you play that into the speed of how we're wanting to ramp up all these wind farms, I can't imagine the lead time on turbines right now when we start to get into the bigger end of orders. A few examples of things we do. So there's a photo on the left there. That's some helical gear changes we did it on an S88 turbine. Next one along, MM92, some up tower bearing changes there. And you can see the specialist tooling involved in each job. GE turbines, the third one along there, the big 5.7 megawatt turbines. So we've just finished all the manuals and the procedures for that. Tooling's finally complete for that. AW 1500 Axionas, that's a full helical up tower change out at Warborough. We do that from time to time too. So every single picture there is a massive cost saving. And in the past, that picture would normally be a gearbox removal and a 6-figure bill. So just coming back to that philosophy approach. The company itself, like I said, we're constantly developing things. We look at every brand of turbine. We look at every brand of gearbox. We're always involving our engineering program into them. We do a lot of pilot programs and a lot of work is done to get the competence every single year to be up to speed with every gearbox and turbine that's getting put into the market. Again, this is back to planning. As you can see, sorry, I'll run back there. Our QA on all of this is quite thorough. We have every single part identified, analysed, put together in kits for the guys. I think the bottom left photo is one of our inventory bays at Dandenong. So we have a turbine down, we have a problem, everything's labelled, the guys can come in and get whatever they need, deploy off to the field. In some cases, we're there the next day. So it's pretty tightly run ship. As I said, that's our first approach. And for any wind farm owners, I think this should always be the approach. And you need to know your failure modes of your fleet. Different turbines, different gearboxes, different failure modes. It'll come with experience. It'll come from a lot of networking and understanding of that turbine. Then you need to match it to your inventory and how often you're doing it and your lead times. Again, lead times if you're in planning right now, you've got to be on your game. Pilot projects, again, turbines are ever changing. It's great to work with the customer and try to understand their challenges and put in place a team approach for a common solution. We try to do that anytime we can. We try to schedule our outage works based on CMAS results as well, so we minimise our turbine downtime. And again, yeah, know your equipment well. I think the best run wind farms are the ones where the wind farm manager's been there for 5+ years. They get on top of it, and the learning curve's done. Learning curves in the wind industry cost a lot of money. Just something to touch on with rush to market at the moment, and I think it's come out a few presenters on the last panel. I think everyone's mentioned turbines are getting bigger. I think every year it's a race to who makes the next bigger turbine. And it's not necessarily a good thing sometimes, but if you look at the evolution of these gearboxes, I think the Blaney wind farm was mentioned by Steve from GE yesterday. 44-metre blades, 600 kilowatt, and I think the gearbox is probably as big as the front of this podium, and 20-something years old now. So they're getting larger and larger. Even onshore, having onshore, we're doing 6 megawatt, and that's massive. So they're getting a lot bigger. Technology is getting bigger, and we need to keep up with it. But with rush to market, it comes the risk. But I guess to school people in the rush to market and how things run, if you're not aware of it, the life, the cheaper the turbine's going to be to produce. So then the turbines become more competitive. So the turbine companies always want a gearbox and drivetrain in the turbine that can take as much power as possible and be as light as possible. The lighter the gearbox, the tower costs come down, everything comes down. They get more competitive. So if you look at turbine gearbox in terms of power, we're talking now about torque density. So how much torque we can get out of a gearbox compared to the weight. So torque's basically the rotational twist into the gearbox. So if you look back at 05, for instance, we get 60 Newton meters per kilo out of a gearbox. And with technology ramping along, we're now squeezing out up to 200 Newton meters per kilo. So that's pushing the limits. We're pushing technology, we're pushing materials all the time. But that comes with a lot of risks, and it comes with a lot of potential issues. Like the rush to market is a pretty big deal. And these gearboxes that are in these wind turbines, they're fairly sized within an inch of their life. I worked in mining for probably 10 years, and a lot of conveyor drives, mill drives, washeries, things like that. If you size a gearbox in the coal industry, they want to make it twice the size of what it should be to handle, oil temperatures, a bad day on the conveyor, whatever the case may be. So there's a bugger factor built in. And mechanical engineers will call it a safety factor or a service factor. So that bugger factor, say on a conveyor drive or a mill drive for a mine, it's normally 2. So they make a gearbox that will handle twice the load that's going to go through it. And the gearbox in mining, it's normally bolted down on a concrete plinth or very secure, nice solid coupling on it. Wind turbines, that safety factor is normally about 1.1, 1.2. So there's not a lot of room for error, and they don't bolt it down to a concrete plinth. They stick it 80 meters in the air and put it on a wobbly drive base and everything else. So everything's going against it. And it's getting, it's getting to the point you look at the safety factors and what's going on out there, and from an engineering point of view, I think you sort of cringe sometimes. It's exciting too. We don't get to where we are without this technology as well, but it's you've got to be quite wary, and you've got to really look after your equipment. When you're in a very narrow window of error with low safety factors, you have to look after your equipment very, very well. So again, how does this race to the top affect the turbine selection so a lot. So every year turbines getting larger, they're more complex. They present logistical and installational challenges, and they don't stabilize. They keep getting more challenging. Ongoing maintenance for us, it means more training, more pilot projects, better inventory understanding, tooling investments. For asset owners, it means a lot of learning curves. It means costs. It means OH&S challenges. It means potential design faults such as serial defects. Again, not a lot of testing goes into them like they used to. Someone drags out another megawatt into a turbine. It runs in the Netherlands for 1 year, and it's one turbine. It doesn't really cover a massive test. And of course, $1 million of rectification work. So I've just put a picture of learning curve exhibit A. That's a brand new turbine, unnamed wind farm, with plain bearings. And the turbine got built and it was left for probably 3 months. No one turned the oil pumps on, and we're already replacing a very expensive gearbox simply because training didn't happen. New technology came out and old rules were used. So you end up with a very, very expensive problem. And then we just need to look at the life cycle. So your average wind farm being 25 years old, it has sort of a large life cycle to it. So big asset to manage. So this is a real holistic look at what you need to do once your turbine's up and running, because your gearbox is probably the most belted up component and most important component to work with. It's probably 30% of your OPEX costs, and when you've got problems, the CapEx costs on them are very, very large. And that's probably it from me. I don't know how quickly I ran through that, but.
Fantastic. Thank you so much, Matthew.
Pleasure.
I actually thought gearboxes only were in cars. I didn't actually know they were in wind turbines. So thank you very much. Unfortunately, we've run out of time. So Matthew, are you happy to take questions afterwards if people want to grab you? Yeah, thank you very much. Okay, so we will now move on to our final keynote speaker, and his name is Simon Preston, and he's from AuWE Industries. He's the Group General Manager there, and he's going to be talking to us today about the Australian supply chain and the renewable construction market. Simon holds a degree in mechanical engineering from the University of New South Wales and has a Master of Business Administration. He's worked in manufacturing for his entire career, well done. And he started off at PGH Bricks before he moved into FMCG manufacturing for Visy Bevcan, and has worked in Europe before becoming a general manager of Precision Oxycut. In 2019, he became a group general manager of Selpucker's engineering division, and he's incredibly passionate about Australia's move towards renewable energy solutions, and equally passionate about the role of Australian manufacturing in delivering the aforementioned outcome. Welcome to the stage.
Thank you, everyone. And thank you very much for sticking around to listen to me towards the end of the day. Appreciate it. So as mentioned, I'm in manufacturing. I'm in Australian manufacturing. I've been in this game for quite a while, a little over 20 years. And I am very, very passionate about Australian manufacturing, so much so that I can sometimes be a little biased. And even in my own procurement decisions, that bias often shows through. So to get straight into it, with regards to your industry, or I like to say our industry, because we play a fairly big part in it already, renewables and Australian manufacturing in it. What are the benefits? So first of all, the obvious ones are that it supports the Australian economy. And the other obvious one that we hear a lot about is local jobs. When people talk about local jobs, and I often think it can be a bit of a throwaway statement, it's often not quantified. So if I can be a little bit more specific and say that in Australian manufacturing, currently, there's 110,000 people already employed. So it's a pretty big number. We're essentially the same sorts of people you guys are. We sit on the same trains as you. We're next to you at the footy stadiums. Our kids go to the same schools your kids go to. We're a reasonably big part of the economy, and we're a reasonably big part of our total community. The next one might be a little bit harder to believe. I'm actually going to make the argument today that I think Australian manufacturing can actually be cheaper for you. Now, that goes against the predisposition of most people's thinking. And we've heard it over the last couple of days here, comments about Australian manufacturing. And a lot of the point of views is that you have to pay a premium for it. And in some cases, that is true. But what the case study I want to go through later will I want to actually prove to you that when measured as an outcome, it can actually be quite considerably cheaper, and not just in the space that I exist in. So presently, what do we do? Sorry, skip along. What does the Australian industry do right now? And there's quite a lot of things. I've thrown a few photos up there. A lot of you will know that we already play in the space of making wind towers. There's more than one company that does that already. In the middle, you can see an anchor cage, which my company made in that particular photo. If you're driving in Sydney on the M2, you'll recognize the blue structure as one of the footbridges over the top of the M2. That was a pretty funky looking bridge and not an easy thing to build, built by one of our customers in Southwest Sydney. The one I like the most actually in this is the right-hand side building. If you can see closely at the bottom of that building on the right-hand side of it, there's a church. So when the people that built this building wanted to build it, they actually wanted to buy the land that the church was on for their foundation. Being a church, there's not a lot of reason to sell. So what they did is they said, well, I'll tell you what, we're going to buy the air above the church. And that's exactly what they did. So they built their building on the foundation that they actually owned, and they went up and then they cantilevered over the top of the church and carried on upwards, giving them the total footprint that they wanted. So we were actually the guys that supplied the beams to do that. But what I like about it is the irony that the good people that frequent said church, when they go to into their wonderful hall, look up to the heavens and pray, they're actually looking at a bunch of lawyers and accountants, which I'm going to argue might bat for the other team. Apologies to the lawyer in the room. So obviously in your space, we make wind towers, we make monopoles for transmission. We've heard a lot about monopoles, and we make brackets for solar. So being a manufacturer, and particularly in the steel industry, you can see why I'm actually sitting in this room and not in the solar room. When you look at solar, the usage of steel is pretty low. When you look at wind, it's really, really high. So you've got 300 tons worth of steel going into most towers in the modern market. So if we average that out, it's about between 60 and 100 ton of fabricated steel per megawatt of generation. If we keep going, what that means is that we've got, if you look at New South Wales on its own and the pipeline that's coming down for the various reses within New South Wales, you've got 11 gigawatts worth of generation required, which is on the lowest side of the spectrum, 600,000 tons of fabricated steel. In rough numbers, that equates to $1.5 billion worth of investment in fabricated steel just for New South Wales alone. So if I skip along on what the effect is on that, using the Biz Oxford Economics Group's model and the multiplier effect, for every $1 million invested in that fabricated steel in the Australian steel industry, you actually create 13 real jobs. And with those 13 real jobs and that money invested, the multiplier effect means that there's a $2.2 million increase to Australia's national GDP. Go back to the $1.5 billion worth of investment needed just for New South Wales, and you've created 19,000 jobs here in our community, in our total community, which is $3.4 billion worth of growth on Australia's GDP. Now that's good for all of us. We've all got houses here. We all live here. We all live in our economy and in our community. If that economy is thriving, we thrive. So historically, we've had some wins and we've had, shall we say, some losses as the Australian steel fabrication industry. When it comes to New South Wales, where there hasn't previously been a government mandate around a proportion of local content, you can see on the right-hand side, the business that I look after has been successful in supplying anchor cages. Now, these are in direct competition to imported anchor cages. Meanwhile, the tower industry hasn't done so well. Further down at Mortlake was part of VRET, the original VRET in Victoria. The towers were supplied locally by, in fact, both of the two tower companies that are capable. And we also did the anchors. When we got to Marrawara 2, VRET was not actually covering that project. And as a result, the towers were imported again, but we still did the anchors. So there's definitely a space, I think, and an opportunity for a little bit more innovation and more content to come into this particular industry. So I guess I should introduce myself and what I do and the company I represent. Selwyn Parker is Australia's largest metal recycling business. So as a result, we are actually the largest supplier of recycled metal into BlueScope's mill in Port Kembla. On a good day, we send them 1,500 tons of recycled steel. And if you stop to think about that for a few seconds and to quantify, a semi-trailer driving down the road has a capacity of 24 tons. So we have to receive, process, and ship out 1,500 tons. That's quite a lot of trucks in and out of our yards. Underneath, I look after the engineering division, which is 3 companies. The first of all is Precision Oxycut, which is the largest plate processing business in Australia. So we buy a significant amount of that steel after it's been turned into raw material, plate or finished product for the mill. We buy that back and process it. We recently, or a couple of years ago, bought All Thread Industries, which actually has a 10 to 15 year history in making anchor bolts. So far, they've made 100 anchors for tower in Australia, which is pretty good. Also capable of a lot of other things. So earlier I heard from Pico, one of the major sponsors, and their capability of making anchors smaller using really, really large bolts, 12 meters long and 100 millimeters in diameter. We're also capable of making that, again, from Australian steel. And we have quite a lot of unique technologies around galvanizing, which doesn't actually exist in other parts of the world. The last company is First Forge, less relevant here. They're a fastener business and have a rather niche market, which is not specifically wind, but can play in the space of tower bolts for assembly. Probably the most important thing about us, though, is when I say, who are we? We're actually your customer. So we spend last year, we spent $3.5 million on electricity. It's quite a lot. I know we're not your biggest customer, but we're not your smallest either. And we're not alone. So we're a reasonably big company as far as fabrication, but we aren't, well, yeah, we are as far as fabrication, but we're not the biggest fabricators in Sydney or for that matter in Australia. By no means are we that. So I wanted to have a discussion, or rather take you guys through a case study. And I mentioned before that we did the project Marrawara. So Marrawara was again outside of VRET. We were in direct competition with imports, and we were approached by the construction companies Environ, who were building it at the time. Now, by the time it actually came to us, we were about 7 weeks out. This is when contracts were signed, 7 weeks out from when they wanted the first anchor on the ground. So we were handed the final design and said, please give us the final price, which we did. We were competitive. So they signed up, and that's when they actually, I suppose if I start by saying what we signed up for, the anchors had an 80 mil ring down the bottom of the anchor, which was about a 5.5 meter diameter ring. The bolts, there was 226 from memory, and those bolts were an M48, which was 3.8 meters long. They weighed 50 kilos each. They were galvanized, which was a grade 10.9 bolt, which means we had to use our special galvanizing techniques, because if you drop a normal bolt, 10.9, into a hot dip gal bath, you'll actually crack it. It's called hydrogen embrittlement. You'll actually break. And if you don't break it in the bath, what will happen is it'll fail when you try to tighten it. So this is another way where we actually do quite well against imports because we have this capability and technology. They asked us to provide a 25mm template to help with the assembly and a few other things that went with it. When we got into the discussions and they'd signed up, they then said, by the way, we've just realized that we've stuffed up. And we said, okay, what have you done? They said, we forgot about the foam ingots you need to make the great pocket trench at the top. So some of you may or may not be familiar. If you're not, you are, apologize for explaining, but at the top of the anchor, you've got this trenching concrete. And what they use it for is to lower the tower down. And once they lower it down, they're able to actually, because grad is a self-leveling medium, they're actually able to put the tower down perfectly flat. You don't have a leaning tower of Pisa. So it's a really, really important part of this particular type of design. So forgetting to do the great pocket foam ingots they thought was going to be a problem. It turned out to be a pretty big problem because when we actually went and got it priced by both a local supplier and one from overseas, the bill was going to be an extra $200,000. So that's when we said, well, look, how about you let us have a little shot at this? Because we'd often wanted to talk about doing assembled delivery of anchor cages. So we started talking through our design. And what we came up with was we said, forget the foam ingot. To start with, they end up in landfill anyway. So what you're doing is you're importing a whole heap of rubber that actually ends up in our landfill in the local tip. So we've talked at this conference about a greener way to build our projects. This definitely isn't one. So what we did is we offered a metal solution. At the end of the day, we make metal or do work with metal. So it made sense. Instead of offering 38 full rings of great pocket foam ingots that were going to go to land waste, we said we will build you 9 steel ones and we'll recycle them and we'll reuse them. We're kind of mentioning the safety factor before. Let's just say we made them maybe a little too strong, but that's okay. But they were so strong, I honestly think they probably could have done between 50 and 100 pours, which means that from a point of view of taking this concept to a bigger wind farm, it makes a lot of sense. So we were able to supply these 9 metal inserts and we were able to do the assembly. And we took the concept of losing $200,000 to the other side of the balance sheet. And Zenvirons were actually now in a situation where they were saving $200,000 using us versus the original scope of an imported flat pack and assembling them on site. And this was only for, now, those numbers are the numbers I understand, but to be fair, that's all they were willing to tell me. Could well have been a much bigger number, but then I might have charged more. So we won't go there. So what this is, and again, for the non-engineers in the room, I don't expect you to fully understand it, but it's essentially just showing you the profile of what we've built. But if I skip across, the thing that we really, really liked about this, and we've since looked at this again in far more detail because we're in the process of building the McIntyre anchor cages, which is kicking off in the early part of next year. We actually looked at the recycled content and the Australian content of what we were doing. Turns out that what we provide for both projects is 97% Australian made. And that doesn't mean I bought it from a guy in Australia who bought it from someone overseas. What that means is you can trace the materials we used all the way back to the guy digging out of the hole somewhere in the desert or Whyalla or wherever. Also, recycled content. Because of the way the suppliers that we actually use, BlueScope has a very high percentage of recycled content. For our bolts, we're actually getting it from a supplier that uses an induction arc furnace, which means he uses 100% recycled steel content. When you get to the plastic components, truth is I never actually even went to see if I could get the parts cheaper from overseas. I found a guy in Orange in regional New South Wales, and he had an injection molding facility. And it turns out that he was actually developed a process where he could actually regrind certain materials and get it up to a 50% recycled content, which in the grand scheme of this project isn't massive, but it's still worth noting. Normal injection molding, you'd see between 15 and 18%. So this is pretty good. On top of that, the really nice story is that he's gone around Sydney and other parts of New South Wales, and he's bought up all of the COVID vaccination waste, which is plastic. He's got it all sitting in his factory and he's regrinding it and he's turning it into plastic components that we're using on the McIntyre wind farm. So it's a really nice little recycled story out of an otherwise pretty terrible situation. So, sorry, I got myself confused with this screen versus the other one. As far as historically, how these things were built. Historically, you would buy this as a flat pack from overseas. What happens is they'd turn up in a container, you'd set your guys on site into destuffing the container, you then put it on a truck, take it out to the hole, build it on site, and essentially a lot of labor-intensive process. What we did, and to put that in perspective, building these anchor cages out on site was taking 4 to 6 people, 1 to 1.5 days with a crane on hire the whole time. What we did is we developed a process where we built and assembled the actual cages into quarter sections. We put them on a truck and we drove them down in quarter sections, unloaded them straight into the hole. And then we developed a number of things, which I'll go through as far as installation jigs, which meant that what they could do is they could now install it with 2 guys in 90 minutes and a crane. So I'll talk through the actual normal day in the life of how this went in a minute. But if I skip through to here, this is actually a picture from my CCTV in the factory. This is my CNC department. You're looking at a brand new, well, it's about a year old now, CNC bed milling machine, which we used. The difference with what we did versus what normally happens in these anchor cages is we actually went away from the cutting tolerances that normally cause you problems in this type of device. So instead of cutting them on an oxy-cut machine and drilling all the holes, which we used to do, to be fair, we actually cut blanks, and you're actually looking at the top forming ring being machined at the point in time, and you can see on the other side on the floor there, the bottom plate's ready to go. What this allowed us to do is this machine can actually accurately cut and trim metal to 0.02 of a millimeter. So instead of having a cutting tolerance, which is up to 3 mil plus or minus on an 80 mil plate, that means that when you make a quarter section, if you want to make 4 of them and put them together, you have to allow for the fact that it could actually be 3 mil too big or 3 mil too small. Now, if it's 3 mil too big, they won't go together, especially if both of them are. So you have to actually cut it undersized to allow for that. But that also means that you could be 3 mil too small. So you can end up with a 6 millimeter gap. And when you put them together, if you put it together and you've got a 6 millimeter gap at one end and not the other, that can actually turn into a 30 millimeter movement of your bolt position. Now, anyone that's lowered a tower onto an anchor cage after the concrete's been poured knows you don't want a 30 millimeter variation in where your bolt is, or you're in a world of trouble. So what we did is we machined this to have a 0.5 millimeter tolerance, or rather position, under a full quarter. And that meant that we could actually get these things to kiss together in installation, and they were already going to be within 1 to 2 mil of perfect positioning. And some of the clever devices we came up meant that we actually got it to 0.5 of a mil. So we were able to build our tower anchor cage in the hole within 90 minutes and get every bolt to be within 0.5 of a millimeter space of where it should be in a 3-dimensional space, sitting 3.5 meters in the air, which we were pretty happy about. And so was our customer. This just shows the same concept. You can see the machined sides on the ends. Those machined sides are absolute, which means, again, down the bottom, when you essentially kiss them together, you have a perfect circle and perfect alignment of your bolts. This position, or this shows the actual top forming grat pocket prior to being assembled. We've assembled it on its own down on the floor to check to see how it went. And this is all part of our stepping through the process ourselves. You can see we've got this spider holding it together at the north, south, east, west. This was the original design, and we had to go away from that because whilst it works on the floor where I can get a crowbar against this and push it to make it line up, when you're 4 meters in the air standing on a rickety ladder and you pull on this thing to try and pull it back with 200 odd bolts holding it up, what happens is your ladder falls over as opposed to it coming where you want it to go. Here we're actually putting it together. So you can see the jig in the foreground where we're building them. And as we're building them, we actually built a full anchor cage in the factory as testing. We did this a few times We actually made a video of it the third time that we did it. And we did that as an instruction video for our customers so they could do it on site. What we did is we did it with 2 people. I was one of them. So there was a definite handicap. And then the third person was a crane driver who wasn't allowed to touch it. So during the filming of the particular video, that was the basic concept. We actually built it in 2 hours. Again, that was our third time we'd ever tried it. So, and not really having any real experience. This was the first one we built. As you can see, by the time we built this one, the top cross members then, instead of being a setting spider, we changed that to a, I don't know what we would call it, spreader bar, I think was the right term, a left and a right hand threaded bolt, which we knocked up in our All Threads factory. And what that meant is that we could turn the coupler and we could either jack the north, south and east, west positions out or in, and using a tape, position it perfectly. And given that every other position of the hole had been CNC machined within 0.02 of a mil accuracy, we knew that if we had our north, south, east, west right, everything was right. The other thing that we did was the top template is actually on a 48 mil. We actually put a 63 mil hole in it, and then we tapered all of our nuts on our lathe. And that meant that you can get the actual thing off once it's been set in concrete. Because if you've got a really tight tolerance, it's not going to pull out very easily, especially, and you're probably going to rip all of your threads off. So we gave it enough room to get it off, and we centered it using those tapered nuts. For the slightly more astute in the room, you may actually be wondering how I got that photo, because it's rather a long way up. And the answer is, when I built this thing the first time, I was so excited, I actually built my own jail. I was inside it. And then we went, oh, bugger, I need to get out. So somebody gave me a harness and they got me out with the crane. And I took the photo as a opportunistic moment. So what did we manage to do? Rapid construction and safe construction. We removed all manual handling from the on-site construction of these items. We essentially brought that all in-house at our factory, but by doing it that way and by building it on the horizontal under our overhead cranes, we were able to remove all that risk. The end result was that Murrawarra was built with 0 incidents for the anchor cages. And we brought the whole thing down to 90-minute installation. We started the project 2 weeks late, not because of us, but because of site issues. And we finished the project 2 weeks earlier than the original. So we pulled 4 weeks out of the total process. At one point, on a request of delivering between 2 and 3 a week, which was our contracted delivery, they were doing 5 pours a week. And the only thing slowing them down was their site crews getting the things out quick enough to give them back to us. So had they bought 11 of those top rings, I think they could have actually run the start of that project 5 weeks, the entire time. If you take that to a planes, and then there's more to come after, Clark Creek, 185 or something of that matter, you still only need the 10 or 11 top forming rings. So your capital investment is the same as what it was for the 38 tower wind farm, and it's stacked up there. So you're actually talking about literally in savings of foam ingots and labor on site, you're actually talking about millions of dollars worth of saving using Australian steel and Australian manufacturing. I've been told I need to be quick. I was lifted after COVID version 1.0, and I went down and I arrived at 11 o'clock on site. As I arrived, my second truck for the day was driving out of the holding yard, having just signed in. So this is the second truck. These 2 guys in the picture were actually the guys that were doing installation on the day, and they had a crane driver with them. The first truck arrived at 7 a.m. By the time I arrived, they had already built the first cage in tower 35 position. It had been tightened up, held down, surveyed, and done. At 11 o'clock, they started, or 11:10 by the time we drove down there, they started unloading this. I stood and watched as they took them off the back of the truck. You may or may not have noticed in the last photo, sorry, that the sections are all pre-slung, and that removed the safety issue of getting onto the truck on site. So a lot of the safety concerns on site were removed. So the guys working into platform ladder were able to connect to the gear and get it off the truck, lower it into the hole. And then essentially while I was stood watching this, they continued to build this. This was taken 10 minutes after my truck waved goodbye and said, thanks boys, see you next week. And the guys kept going with the assembly. And by 1 p.m, they'd actually finished putting the 4 bits together and got back to the compound for the sausage sizzle. So they're pretty happy. So in short, the solution that we came up with, I'm going to argue is cheaper, because it definitely was. It was 100% safer, it was quicker, and it was greener. And I guess I'll leave you with one point. That's what we did on one project with anchor cages. Imagine what my friends and I could do with towers. Thank you. Time for questions or not? No? No worries.
So thank you, Simon, for that insightful presentation. It's always good to know where the components come from, and obviously with the local content requirements, that's very important as well. So feel free to reach out to Simon in the networking time that we have right now. And if you could come back probably 5 or 10 past 4, that would be great for the last panel section of the day. Thank you.
Actually ends up showing up on here. Yeah, and I think they also come up on screen here.
Well, I might be able to do that.
So at least you can then
So I don't have
see.
to. I
It
don't
might
have to
just
worry
be
about that.
worthwhile just looking over your shoulder just to make sure you can actually see their ugly face.
Yes, yes. Well, it may be to just here, which is all I need.
Yeah, exactly. Exactly.
We're not going to need that. Is this water someone else's?
That
someone
quite
else's.
possibly
Maybe we'll-
is. Yeah.
Oh, that's full. Yeah.
It's a nice crowd.
Yeah. Yep. No, it's good.
Are you there? Hi, Shikar. I'm from the venue. I just wanted to do a quick microphone and camera test before we went live.
Can you, I mean, I can, but I'm assuming.
The microphone's fine, and yeah, the camera's great too. Thanks, mate.
Right,
we'll be going live and.
All right, sure. Thanks.
Cool.
Just checking. It is. It's a very nice school. Yeah, it's all about
Right, good afternoon, ladies and gentlemen. Welcome back. We're in the final session. We're almost there to the end of the conference, unfortunately, of course. But we have a fantastic panel lined up to address our final panel conversation, which is all about optimising performance of wind energy. And our moderator for this session is David Miller. He's a director and principal consultant at Millennium Energy Solutions. He currently provides engineering, commercial, technical advisory services to the energy industry and specialises in the large-scale wind and solar energy industries here in Australia, Southeast Asia, India, South Korea and China. Massive geography to cover there. How can you specialise? Previously, he was head of project delivery for Total Aaron in Australia, and he established AECOM's Australia's renewable energy team and has worked on over 2,000 megawatts, 2 gigawatts worth of wind and solar projects. Welcome to the stage, David, and may I ask the other panellists to also join him as well.
Thank you, Andrea. Welcome, everyone. I hope we're all awake and energised. I'll try and inject some enthusiasm to the last session of the afternoon. And I have to mention the cricket score. Australia got them all out for 147, I think. So hopefully that will get the Aussies going. Apologies for Chris. Any Englishmen in the audience. Let's get straight into it. We've got 50 minutes, and I hope it'll be a really interesting discussion on wind energy and wind farm portfolios. We've got a really diverse group here this afternoon. I think Chikara is on the screen here as well. And I wanted to just introduce wind farms and the extent to which it adds to the Australia's energy industry. At 35.9% of Australia's clean energy came from wind energy. And in 2020, 9.9% of the overall electricity came from wind energy. And as we know, it's on the rapid increase. And last year, there was 1 gigawatt of capacity added, 1 gigawatt wind farms, let's say, 1,000 megawatts, added into the grid in 2020, that's last year. And at the end of 2020, just one more stat, 21 wind farms were under construction with a capacity of more than 4 gigawatts under construction or financially committed nationally. So we're talking about a big industry employing a lot of people. We're talking about literally thousands of wind turbines of various types. We've got a cumulative capacity at the end of last year was 7,500 megawatts. So it's a really big industry. It's here and it's a really important topic to talk about. So what I'd like to do is I was going to say contestant, that's probably not quite correct terminology, the panelists to introduce themselves briefly, and then we'll get into a bit of discussion. So perhaps, Pedro, would you like to kick off?
Yeah, thanks, David. I'm Pedro Vazon. I've been with RES Australia as technical manager for about 4 years, and in the wind industry since 2005. In the past year, I've been helping the local asset management business bring some of the additional services that RES provide in the UK into the local business, of which analysis and optimization of wind turbines, condition monitoring services, that sort of thing. RES, you're probably more aware of RES as a developer. We also do provide construction management and asset management services, both here in Australia and the rest of the world.
Internationally. Yeah, great. Thanks, Pedro. Chris?
Good afternoon, everyone. Yeah, it's more of a snooker school than a cricket school.
Not the English accent there, yep.
But look, I'm Chris Baldwin. I've been with Meridian Energy in New Zealand and Australia more recently for 12 years. Here in Australia, we've got a small but eclectic portfolio. We've got a couple of operational wind farms, Vic and SA. And we've got a couple of contracted farms and got 3 hydro units that I was told not to forget about. So I in terms of my input today, it's more from an owner and asset management perspective. We've got a small portfolio of about 200 megawatts. We've got a couple of different models that are quite unique as well. The Anacons in SA and some. So we outsource the turbine maintenance at Symbian Farm. We do a lot of it in-house down in SA.
Great. Thanks, Chris. Michael.
Hello, everyone. Michael Sherry is my name. I'm the Director of Wind Product and Business Development for Green Power Monitor. So Green Power Monitor is a DNV company. It makes more 2 doors down in the solar space. We supply SCADA hardware and software to wind, solar, and plants. So GPM was acquired by 2016, and since then, I'm building in DNV's domain knowledge within our product offerings. Personally, I have a background in wind turbine aerodynamics and worked in industry assessing SCADA data for a number of years. So what I'd bring today is some insights into how asset owners can optimize the performance of their wind farms.
Thanks, Michael. Good. We'll cross to Shekhar Kamath, who's virtual. Hello, Shekhar. How are you?
Yeah,
You there?
I'm here. Can you hear me?
Good. Yes, thank you.
Yeah, I just have to say that because I mean, having joined virtually, that's definitely it's either you're speaking on mute or can you hear me? So those are 2 things that are pretty standard now. But from my perspective, thanks. Just a quick background. I'm actually based in India. Kind of that's the reason why I'm not able to travel as well. But from a professional background perspective, I have about 2 decades of experience, mainly in the power industry, working in the process automation side, but also lately setting up control centers, both for conventional as well as renewable generators. In my current role, I lead sales and business development for APAC for a company called New Focus Insights, that some of you may be aware is a Vestas company. We were acquired in 2018. We still are true to the original founding mission, which is we are in the space of energy analytics, headquartered in New York, focusing on 3 distinct use cases for generators, which is around asset visualization, power forecasting, and asset failure prediction. So that's about me and about New Focus.
Okay, thank you, Shekhar. Thank you for that introduction. Look, what if we've got a few questions that we'll talk about today, and then at the end, hopefully there'll be a few minutes time for some questions. So please think up some questions you'd like to ask the panel. We'll kick off by asking the team here, in their experience with wind farm portfolio operation, what key issues have they come across? And if known, what techniques have been used to improve or rectify them? I think we'll go to Pedro first up, if you wouldn't mind.
Yeah, thanks. So I think we have a couple of different scenarios. So both locally with, I guess, a slightly less mature industry and overseas in the UK as well. So here we're seeing one of the big issues is just delay in startup of the wind turbines. So we get curtailed off, whether it's because of grid or because of negative pricing. And we're seeing that there's a long time to get the turbines synchronized with the grid and up and running again. And so, yeah, that just causes obviously more lost energy than needed. We found that ways to get around this, to improve this at least, is when it is negative pricing, to go to a bidding strategy that doesn't shut off the wind farm, but just curtails the turbines down, so generates at a lower level. And that completely skirts around the issue of having to resynchronize with the grid. On the other side, when we do have to curtail out, it's really been about working with the turbine OEM, collaborating with them to just find ways to get it to synchronize quicker and to lose less time.
Just on that though, are they taking longer to synchronize than they were expected to? They were designed to, or is it a bit of a shock that?
It is. I think, yeah, just more recently, we've seen a lot more negative pricing, a lot more curtailment in the grid. So I don't think anybody expected this to occur as often as it does these days.
Okay.
So it's just becoming a bigger issue.
Sorry, I interrupted.
That's all right. Yeah, another issue, a big issue that we see here in this market, which I think will be a question for later as well, is just FCAS cause or pays charges, much higher than expected over the past couple of years. And yeah, we found self-forecasting to be particularly effective on that.
Okay, and we'll talk about that in a bit. Yeah.
Yeah.
Okay.
And then just on the overseas, our experience in the UK and in Europe, one of the key items that we really need to look after, just the correct setting up of the turbines from day one. We are in both markets a developer, and then we take on construction and asset manager of the projects, and we do see that a lot of times the initial settings, curtailment, noise curtailment, load management aren't correctly set up from day one. So in effect, the turbines start as being suboptimal performing. And that's really, again, a bigger loss. And our main technique there is really to audit the curtailment strategies from day one, just work with the OEM to make sure they're well implemented. And especially to do with, I guess, the yawing, the northing of the turbines is sit through the OEM in the first few turbines to just make sure that they're setting things up correctly, have a good process to do that, so that from day one, the turbines are properly aligned.
Okay, thanks, Pedro. Chris, got a couple of observations from yourself?
Yeah, well, look, the main two, and there's been a bit of a consistent theme throughout the conference. One of them for us is certainly technical expertise. It's very thin on the ground, certainly for when you've got unique turbines, when you haven't got the run of the mill. So yeah, especially when you don't have an OEM that's supporting you in country, and potentially an OEM that it is no longer.
You got both.
I do have both. So yeah, it's been an interesting journey last 3 years, and we are on a bit of a journey, I think. So I think the key things for me is people. I think the data that we'll talk about obviously is really important, but it's actually having the right people and the right expertise to look at that data, translate it, and actually come up with a plan and then implement it. So I mean, all part of that is just building a motivated and engaged team. We have a very small team, but that's what we've got, and then really sort of giving them learning opportunities on the job. And that can be really simple things like when you do get the specialists that come over from wherever they've come, whether it's Europe or interstate, teaming them up with your younger technicians and making sure knowledge is transferred over. So that's a big one for us. The other is really about the OEMs and their IP and how precious they are of their IP, even if your turbines are 15 years old. So you have to be kind of creative in that space, and you have to give your team time to do the research and build the relationships, and join groups like O2O Wind, and then sit on those at 8 o'clock till 10 o'clock at night, because they're mainly joined by people out of Europe. And then I think, so just developing that team, upskilling them, and taking a few calculated risks to get everything done. So yeah, they're the main two for us. And another point on talent is really, as an industry, we've got to make sure that we're developing the younger people, whether they're coming over from PV or if they're coming over from oil and gas, wherever they're coming from. Yeah, just encouraging that knowledge sharing between the more experienced techs and the younger ones coming through.
It's certainly a big issue, isn't it? The resourcing side for sure.
Yeah.
Michael, you got a couple of points you'd like to mention?
Sure. Yeah, so Pedro touched on it earlier, or some parts of it. So, I mean, obviously you need to get your turbine spinning first and foremost. Kind of that requires robust monitoring. So how do you do that? Do you do that through the OEM systems or a kind of secondary SCADA system? We find that customers have more of a problem the more their portfolio grows. And if they have multiple kind of OEM systems, then you're dealing with multiple OEM SCADA systems. So just don't forget that it's your data and you can do what you want with it. I mean, they may not tell you the answer with the IP, but you still should get access to it. It's whether you want access to it. So you have the technical expertise in-house to process that data. But there are solutions out there. So that might be, Pedro offering the asset management, or there's software solutions like Shekhar and myself that can assist that process to collate, standardize, and almost understand what the OEM, what's in their SCADA data. So not every OEM is the same, but there's a lot you can do with that data. Again, moving away from the physical aspect, but there's a lot of information there that you can use to understand how your portfolio is operating.
Okay, no, thank you. Well, we might cross to on the second question to Shekhar straight up. So this was a question around what new techniques are being developed in Australia or internationally to deliver improved wind farm portfolio performance for owners and asset managers. So Shekhar, I wondered if you had a comment on that topic.
Sure, David. So I do want to address what Chris also kind of briefly touched upon in his comment about the lack or the limitations on expertise on the ground. And I think part of it is to do with the fact that the wind and solar industry are highly fragmented. Assets are kind of scattered quite geographically widely. And therefore, the access to data that Michael brought up, right, which is data, information, and then kind of knowledge, which kind of leads to expertise. So I think that's where I see the role that digital solutions and more of the innovation around digital solutions around bridging that gap between the asset and the people on the ground who actually are responsible for managing those assets. Obviously, I mean, most of us are aware of kind of portfolio-wide monitoring solutions that drill down, allow users to drill down all the way from the fleet to a farm to, let's say, a specific turbine, and also provide that depth of analysis, which goes beyond just superficial monitoring, but actually gets down into root cause analysis or diagnostics, identifying what may be specifically going wrong in a particular asset. Those are technologies that have been around, or at least have been adopted at scale as well. One of the things that, I mean, in addition to all of this, I mean, we at Utopus are also looking at something unique at the moment. It's currently in early stages of trial, but it's around the whole concept of benchmarking. So especially for large, what we see is for large owner operators, which have a large and diverse fleet, they have the ability to kind of compare and kind of contrast what the performance is across various sites or various farms within their portfolio. But the actual value of that benchmarking is kind of limited by the amount of the scale of your particular assets. What we are at Utopus Insights are doing, we have 100 gigawatt of assets on our platform that we are looking at, in some ways unlocking the insights from that data to be able to allow, let's say, small or limited fleet operators visibility into how they perform vis-a-vis, let's say, their peers in the industry. Of course, we want to be mindful of privacy. At the same time, we want to be able to make a fair comparison based on age, model, asset type, and such. But I think that's an area that we've kind of recently explored, and I mean, like I said, it's still early, but we're very excited at being able to provide some level of benchmarking across operators.
Okay, no, thank you, Shekhar. Michael, I know you had some thoughts on that topic.
I'm not sure Shekhar got to the second question, but
sorry, thank you. I cut you off. Sorry, Shekhar.
Yeah. No, the second part that I was mentioning, the innovation part, is what we're seeing is that there is a lot of depth of analysis, Michael, like you mentioned, all the way from fleet-wide monitoring to, let's say, identifying specific subcomponents of the turbine that may be underperforming. But the innovation that, or one of the areas of improvement that we kind of see is the breadth, which is how do we take learnings from one side and actually be able to apply it to a completely different site, completely different operator. It requires, I mean, like I said, it requires for us to be able to unlock some of the information and knowledge that's hidden within the data across our 100 gigawatt of assets that we monitor, while obviously maintaining the privacy and confidentiality of individual operators. That's absolutely paramount. So that's an area that we find to be is something that has not been explored to the extent that it could be by the industry so far.
Are you finding that portfolio owners are comfortable about sharing their information and knowing that it's being looked at by other operators?
Fundamentally, I mean, the question about one, it's a two-way street, right? So the larger operators may have certain concerns because they might think that they have a sufficient amount of comparison points within their portfolio, so they don't want to really someone else to benefit from it.
Yeah.
But it works both ways, right? So if you share, you also receive insight from others. The other aspect is this information is completely anonymized, and not only from a legal perspective, but also, like you said, the concerns that customers have around is let's say specific information about their asset visible in a very identifiable manner to an external agency, and that's obviously the privacy that we will keep. That's absolutely paramount. Most of the data is anonymized, but also averaged. So there's no way to trace or identify, let's say, a very specific aspect of a specific farm. It's kind of designed to be more of a guidance KPI, because most of the benchmarks that we see companies or operators operate on are either manufacturer set or something that is kind of based on historical record. But this is something that we believe is, again, not designed to be specific in terms of saying, hey, this is what the farm down the road is doing. It's more around, hey, what is the average, let's say, performance of a farm of this age, this vintage, in this specific in this geography, and the geography may not be New South Wales, it may be all of Australia. So unless we have those many data points, it would be unfair and incorrect on our part to even share that analysis. So there's going to be filters in terms of having a sufficient minimum data set before we make that parameter available to customers.
Yeah. Okay. No, thank you for that, Michael.
Yeah, sure. And following on from what Shekhar said, so DNV has a long history of kind of operational analysis of wind farms, and we also have a kind of an operational database of plants, which we have done for due diligence processes. And from that, and those processes have been automated into, I'm sure you've heard the word, like a digital twin. So that's kind of coming into the markets now, where it's just a numerical representation of your asset, and it gives guidance about how the asset should perform. So Shekhar touched on it in terms of a benchmarking perspective. Actual curve, you can flag, you can create a ticket within your SCADA system to investigate. So the capabilities of digital twins, they vary from just being descriptive, telling me what my asset is doing at the moment, all the way up to the holy grail of an autonomous system. I don't think we'll get there to an autonomous system. We'll still need the oversight. But within our digital twins called Wind Gemini, and the kind of capability statements vary from kind of descriptive, diagnostic, and predictive. So you're getting more complex as you go up. So on the predictive side, we have like a turbine lifetime estimator. So we all know that turbines are designed as per the IEC standard for a particular location. And that states that the turbine will face 8.5 meters per second, certain shear for the lifetime over that 20 years. When you attach that to an aeroelastic model of the turbine and feed it with kind of real-time SCADA data, you can see how your turbine is faring against the design case. So it really comes into play with kind of remaining lifetime discussions, ending lifetime. So those tools are in the market. I'm also seeing kind of a prescriptive tool, where that's like a failure mode and effects analysis. So if you see this in your SCADA, then this might be the cause and this is what you should do. So it's these digital twins are becoming more complex, which is a good thing. We're using data to aid decisions. They'll never replace a competent engineer, but they're just there to assist people in
provide the information. Yeah. So have you seen that when you with Rez? Is that what you
Yeah, absolutely. So yeah, picking up on a lot of those buzzwords, certainly digital twins is something that we're
you got
we're
digital
doing.
twins? Are you?
No, not particularly. I'm a bit taller. So yeah, we do use digital twins. So obviously we use machine learning to train up the models to understand what the ideal turbine behavior should be.
Is that Res International? Is that?
Yeah, that's done mostly out of the UK that they do most of this training. We have most of our people doing that there, and here I guess we're more the physical arm of things. So I guess to us, one of the key aspects is yes, there's the artificial intelligence aspect, but most importantly, there's also the human intelligence. So obviously we pick up these flags, we pick up these issues. It's never a describer to go change that bolt or tighten that relay. It's more about this is producing less at these areas. So then it's up to the person to go in, to dig in, understand the root cause, understand what are the fixes about this. Yeah. And it, going to what Michael was saying, if you have OEM SCADAs, you also have the red flags, but you'll die by red flags if you look at those, because it's very hard to pick up what's relevant to what's not relevant, and that's one of the things that our models help do.
Yeah. Okay. Did you want anything else for that topic? No. That's right. Okay. Well, let's go on to the last question, and then we can.
I was going to.
Oh, sorry, Chris.
Yeah.
Sorry.
So
David,
we don't do anything as complex as what you guys are talking about, and we have a far more simplistic approach. We tend to just look at our main faults and prioritize them, and then each year we just choose a few of them. We figure out, right, this year we're going to roll out a project, figure out what the root cause is, fix it, roll that out across the turbines. I mean, and that seems to work for us. Sometimes they're very, very simple and as simple as rolling out new cable ties across a certain piece of kit, but just by doing simple things like that as part of annual maintenance, over the last 18 months, we've seen about a 20% drop in faults just by rolling some of these things out. A larger project that we did is we retrofitted some condition monitoring systems onto our older kit down at Mount Miller, and that's been amazing. So the business case for that was essentially if we can save one hub, a couple of bearings, either or that system across the whole farm pays for itself. And we've already found one bearing that we've changed out before. But that crept down to the rear bearing, and we've got a bigger problem. So yeah, there's things like that you can probably practical than
the digital twins, but
still using data though.
It is still using data. Yeah, just not as complex.
Just one more thing, Dave, on that question. So I think the question was alluding to, within the market as well, what can people do here and overseas, and kind of wake steering. We've heard that kind of being talked about throughout the conference. I think GE mentioned it the other day. So that's something which could be considered, and I think Pedro can talk to it more than I. But you have to work with the OEM as well in that space.
I mean, do you want to touch on wake steering?
Yeah, sure. So that's a project that Res is doing at the moment. So we don't have a product offer yet because we are still in that trial stage. But actually, using an existing wind farm to change yawing on turbines, change yawing on the upstream wind turbines, seeing the effects on the downstream turbines, basically toggling the system on and off. So we have a statistically relevant data set to check that we are in fact improving energy yield, reducing loads, turbulence induced loads on the downstream turbines, and we are in fact improving the generation and the outcomes for the,
It's
for the
all about
project.
minimizing wake effects
collectively.
Yeah.
Okay. Okay. Very interesting. Look, we'll just go on to the last question, and then we can open up the floor if there are questions. And it's talking, I think someone mentioned it earlier, self-forecasting, but relating to self-forecasting of wind farms, if you could comment on the experience of such a service and the relative value that can be obtained. Shekhar, I think if we cross to you, you had a comment on that topic.
Actually, I mean, that's a topic that is kind of close to my heart because that was the first time I actually got exposed to the Australian wind energy industry itself. So this was back in 2018, and the ARENA funded projects. We actually collaborated with Vestas and one of the kind of wind farm owners from Vestas to kind of, I mean, at the time back in 2018, the only 5-minute forecast that was provided for the purpose of dispatch was from AWE. And the challenge was to develop a system that would at least be at par with what AWE is doing in terms of accuracies. So, I mean, we experimented with a ton of stuff. We actually had a MetMaster installed at that particular site as an additional parameter to be measured. We used a ton of SCADA data, and it was supposed to last a 12-month period during which we evaluated, I think, about 8 or 12 models, which is, these are data models, to be able to try and beat AWE's in terms of accuracy. Of course, at the end of the ARENA pilot, when we did consolidate all of our results, we did realize that we had managed to achieve about a 15% improvement in terms of accuracy on what's called MAE metric, which is mean absolute error. But what was interesting was the actual 15% improvement in MAE translated to about more than 25% improvement or reduction in terms of penalties, which is measured in terms of CPF. So all in all, of course, I mean, what's exciting is that the whole ARENA, and I know that Chris here on the panel, I was also part of the ARENA funded pilot. And so the thing is that has opened up the possibilities for essentially operators and owners to be able to provide their own forecasts, which was not possible in Australia till recently. Of course, that's the norm in the rest of the world. In the rest of the world, there's a regulation that comes out, and every participant in the market has to provide their own forecast. But Australia kind of chose to do it differently. Obviously, I mean, it makes sense looking back. But I think it's exciting that there have been changes based on the overall evolution of the entire grid. So one of those changes was the whole primary frequency response that came in, kind of stabilized the grid frequency around 50. And recently, through advancements in AEMO's own technical infrastructure, they've actually advanced the gate closure, which is basically the deadline before which we need to submit the forecast, down from about 70 seconds before the start of the clock to about as close as 15 seconds, which is as close as to can you get to real-time dispatching. So it's obviously more power to the self-forecasters is kind of clearly the message. And there, I mean, like I mentioned, we are not the only players, but there are a variety of players to choose from when it comes to self-forecasting, and the performance in terms of reduced CPF is kind of an obvious commercial benefit of choosing to self-forecast as well.
Okay, no, thank you, Shekhar. Michael, did you have a comment on self-forecasting?
Not too much. So forecasting is obviously very important for maintenance scheduling. You want to increase your energy-based availability. That's kind of standard, I guess. And self-forecasting is one way to take control of that kind of process, I guess, and then extend it to AEMO. Or deliver those forecasts to AEMO.
Yeah, okay. Did you guys want to comment on it all on self-forecasting?
No, look, we self-forecast at one of our farms, and we're looking to roll it out to the other. So that'll tell you something. It's definitely a worthwhile thing to do. I think that the main benefit of it is the way that it will mitigate your risk for those sort of unusual system events where you're using the standard forecast, you're going to get hit pretty bad. But if you're self-forecasting, you make your own destiny in that space. That's where I see the main benefit of self-forecasting.
Yep.
Yeah, sure. I mean, really quickly, we don't have our own self-forecasting system. We do assess what's in the market and provide it as, I guess, advice to our clients. And yeah, like Sheka was saying, similar sort of impacts on revenue from 25 to 40% is pretty normal. We've seen some projects up to 80% savings on the FCAS costs because of self-forecasting. So definitely a worthwhile thing to consider.
No, that's really interesting. Look, just as a way we're wrapping up, wondering if everyone you guys just think of one point that's particularly salient with respect to performance of portfolios, like as what we've been talking about. It might just go around the four of you, and then we'll open the floor to any questions. Maybe Sheka, have you got just one key point about the performance of wind energy portfolios you want to summarise with?
Yeah, I think when you're talking about, so one of my key points would be that when you look at digital solutions as a way to kind of manage both technically, manage your assets technically as well as commercially. So with the solutions which kind of try to address the commercial aspect of like forecasting, they are just as important or along those lines. So I say digital solutions have the entire spectrum of kind of tools required to kind of ease both the commercial and technical aspects of managing a wind farm.
Okay, thank you. Michael.
You're just following on from that. Data doesn't have to be scary. You can kind of do whatever you want with it. There's a lot of value there that can be kind of harnessed to peer-to-peer comparisons, as people mentioned. If you have within your wind farm, within wind farms, to learn and then to be able to put measures in place or programs in place to achieve that optimization.
Yeah, for me, I think there's no quick, easy fix on this stuff. It's continuous improvement. Don't expect it to be turned around.
Sounds like having good.
Yeah, I think
is that both in-house and externally?
Absolutely. Yeah, you've got to put a good team together. You've got to make sure that the getting the data and it flows to the right people that can and liaising with your site team is so valuable in that space. Yeah, that's the main thing.
Yeah, and from my perspective, it's really that the asset manager and the project has a program for continuous improvement, for improving the value. One thing that sticks with me when looking at pre-construction projects is, or on a specific project, 1% of yield was worth $5 million of NPV. So if you have a program that bit by bit chips away and gets you to 1%, that's real value that we're providing to our clients.
No, that's great. Thank you for that. Now we've got some time. We've got 5 or 6 minutes for questions. Could I throw open to the floor? If you've got some questions for these experienced portfolio managers and consultants. There we go. Yep. Because I've got some questions for you if we haven't got it. Yeah, no cricket questions.
Thanks everyone for the great conversation. So Steph Easton from Iberdrola, Australia. I guess from an asset management point of view, but even trends that you're seeing in data analytics and performance monitoring, aging wind turbine fleets in Australia is, I think, kind of on the horizon as we kind of fit these amazing targets by 2030. I start hitting some hitting their kind of 20-year anniversary. How are you guys thinking about that from an asset management point of view? And also, are there any trends that you're starting to see with turbines that are kind of fitting that 15-20-year life?
That was one of my questions. Well done. Come on, guys.
Yeah, look, with each wind farm is different, and each will have emerging issues as they get through their life. I think trying to think forward to a time where you might need to replace blades. You will have several gearboxes going in a year. That's what you've got to start thinking about. So yeah, for those older wind farms, that's what you've got to build into your plan. And yeah, your CFO is not going to like you for it, but yeah, you need to really put it on the table and make sure that people are aware that's the sort of investment you're going to need later on in the wind farm life. So yeah, that would be the main thing for me.
Well, I guess on that topic, I mean, are you saying, because you'd all be aware of wind farms that are at their 15, 20 years, perhaps in Australia, and are you seeing some of the availability performances perhaps dropping, and you've got some worries that they mightn't achieve what you've been told they would? Or
if you don't look after them, though, yeah, absolutely.
Yeah.
And yeah, you've got to keep on top of it, and sometimes that needs a little bit of a top up to what you would normally do on an annual basis. So yeah, we've certainly found that down at Miller. Yeah, in recent years we've done a bit extra, but we're seeing the results from doing a little bit extra. So not just sticking to the normal OEM checklist and doing that every year. You need to go above and beyond.
Yeah. I mean, did you guys from Res, you got any thoughts on?
Yeah, certainly. I mean, just jumping up what Chris was saying, I think a key point is really staying on top of the CMS data, really understanding how the turbines are aging. We do at clients' request an analysis, basically whether it's a life extension of the project or a repowering, and kind of balance out, which is the best economically for the owners to do. Because obviously there's might be benefits in both. It'll depend on tariff structures and things like that, but there's certainly a calculus to look at it and to make that decision at the right point in time. Especially because, if it is repowering, we're usually talking about almost a redevelopment. That's almost going for permitting again. We'll have to dig new trenches, put new cables.
It's a complete changeover, isn't it? Yeah. Oh, you mentioned CMS condition monitoring. That was another question I had, and maybe of interest to the audience. Are you seeing a rapid increase in the amount of sophistication of condition monitoring, and it's rolling out to these projects, or has it pretty much been the same for the last 5 years and you don't see it changing? Or how valuable is it? I guess condition monitoring, how are you seeing it?
Yeah, so I think it's becoming more normal that projects do have condition monitoring systems provided, but I do think that a lot of times it's not properly used, so it's kind of left to the OEM. This is for the OEM to decide when to replace parts.
All your data gathers up.
That's right. And they have an availability warranty, so they'll figure out when to swap out parts and things like that. Whereas our viewpoint is more that, again, this is the client's data, this is the asset owner's data, and it's of benefit to have an independent person to look at that and kind of challenge the OEM a bit on what their strategies are and what should be replaced, and we see that as very valuable as well.
Okay.
We're definitely seeing the benefit of it. We were lucky enough to have an in-house team in New Zealand that a reliability team that's what they do all day long. They're looking at 8 different farms, and yeah, they'll ping us a message if something unusual crops up. And yeah, I mentioned it earlier. We've only had it in probably just over a year, and yeah, we've already replaced one front bearing because of that, and we wouldn't have picked it up just doing resampling. We wouldn't have found it.
Very interesting. Time for one more question.
Simon Anderson from AGL. Thanks for the great conversation from the panel. Just pretty interested in the performance. You mentioned sort of CMS data, comparing that from OEMs and your own analysis. And just wanted to know, I think Chris mentioned you do a lot of in-house sort of monitoring, and like how far does that stretch? Are you guys doing your own sort of in-house maintenance, or is that still outsourced? And I guess for the rest of the panel, is there a real opportunity for third parties and doing your own servicing in Australia, or is it still relying on OEMs? Is there too much of a risk there at the moment?
So we do both. So at a larger farm, we outsource the turbine maintenance, but we organise everything else ourselves. Down at Mount Miller, I call it a hybrid, but it's mostly us. We have some techs that we employ that do most of the work, and then we supplement that with other contractors to deal with the peaks. So yeah, it's possible. It's not risk-free. It depends on your risk appetite and the risk appetite of your executive team. But yes, it's absolutely possible. But yeah, I wouldn't say it's easy. It's definitely challenging at times. You need to understand that if you're not first on the list for the OEM, then you're sort of poor cousin. So you need to order your parts a year in advance, not 3 months in advance. So because yeah, otherwise they won't arrive in time. But yeah, it's absolutely possible.
Did you want to comment on?
Yeah, and yeah, res in this market, we don't do the OEM. Most of the projects that we have under asset management are have very long-term service agreements, so we can't really inject into that. But it's still, I think, very worthwhile to have an advocate for the owner to challenge the OEM's decisions or conclusions in terms of what needs to be done. And we've seen cases in which the OEM thought the issue was one thing, and we've showed them with the data that actually the root cause was another problem, and saved a fair bit of money doing that.
That's really interesting. Look, I think perhaps it's time to wrap up. We're right on the right time. I think it's been a really interesting discussion, and I think it's come up time and time again that the access to data, getting the data, and then using the data, having the right sort of people with the experience to be able to use it sounds like it's very powerful. So they're the things that have come out for me. So thanks very much. Thanks, Shekhar in India, and thanks, guys, for being part of it today. And if you wouldn't mind thanking the panel, that'd be fantastic. Thank you.
And thanks to you, David, too, for doing such a great job moderating that discussion. I thought it was absolutely terrific. And thanks so much to the panelists as well, Shekhar, Chris, Pedro and Michael. So we're almost there. We've almost finished. Can you believe it? I know we're all probably exhausted because all of a sudden we've been at a conference I'd just like to conclude by looking at wind from a financial perspective. And there was some conversation there around it being really critical for Australia's policies to be able to be competitive on the global scale to help attract investment into Australia. And in particular, for there to be policy certainty in a domestic market, particularly when our investors, we know that they're looking at assets that have a 20 or 30 years sort of life. We also discussed and heard from the panelists around the risks associated with curtailment, connection delays and commissioning. I'm not going to go on about those. I think we've all heard the war stories associated with them. We then went on and heard about the importance of stakeholder engagement, making sure that we prioritise build relationships in the community and they're early and having conversations with the community leaders, making sure that we don't treat stakeholder engagement just like a tick the box exercise, something that we've just got to do to satisfy financial closure on a particular project. We also heard that it takes time to actually develop real relationships, and it certainly can't be rushed. We also know that it is going to be even more important as our grid transitions to a decarbonised state. As we roll out more projects, the importance of stakeholder engagement is only going to rise in prominence. You also heard from Casper, the CEO at Star of the South, on the role of offshore wind in helping to diversify our energy system. And in particular, he was talking about the complementary element of the offshore, the weather resources off the coast of Gippsland, complementing the onshore wind projects in the western part of Victoria, which I hadn't realised. So that was a big learning for me. We then went on and heard about construction and the fact that the blades and towers that make up the wind farms today have certainly changed dramatically over the last decade or so, but certainly there's some challenges there with the design and construction side of the rollout, and the need to continue to innovate and create new solutions to ensure that the construction side of things moves forward. We then went and had a panel discussion about the offshore business models, and we heard how offshore technology is heading closer towards the Asia Pacific region, and that means that there's going to be opportunities for us to learn a lot more from what's happening in the Asia Pacific region and leverage off that expertise here into Australia. We also heard that there's a massive opportunity to build out both onshore and offshore wind projects, particularly as we race to decarbonise our grid, but that we also try to supply green energy for green products that are emerging, like green steel and also green hydrogen. We then had a look at manufacturing and wind farm maintenance. What we heard was that there's significant expertise here locally that we could be capitalising on and leveraging. And what I also learned is that gearboxes aren't just things that sit in cars, that they actually also have a role in wind turbines, but also that maintenance of those gearboxes is increasingly moving offshore, and that comes with a cost to the project developers, but also a cost in terms of carbon. So one of the other things that I heard today was that whilst we're producing green energy, we also want to make sure that the embodied energy, the embodied carbon within the wind turbines that we're creating move towards a lower carbon footprint. So that, in conclusion, is my wrap up of today. I know that there was probably a truckload more learnings for all of you out there today. I know that I've really enjoyed the conversations. I do want to thank every single panelist, speaker and moderator for contributing today. I've really appreciated your insights and enthusiasm. And of course, to thank you all for participating, in the Q&A, but equally paying attention and listening with respect to our panelists and speakers. So I hope you've all enjoyed it, and I'll now hand over to Charlie.
Thanks, Adrian. That was a very good summary of today. Thank you. I'd like to start off by just thanking Leaders Associates, to give us a reason to get out of our active wears and actually be active and, mingle and seeing people that we haven't seen for the past 2 years. And I say this is because, they pretty much ran this remotely, and I thought that was pretty impressive. And they spent a lot of time doing this. And of course, there's a feedback session afterwards, as with all of this. So appreciate it if you could provide some feedback, either in the form of a survey or whatnot that you'll be receiving. And please visit their website if you like for upcoming events in 2022. And I hope to see you all in person in the next events from Leader Associates. And on behalf of them, thank you and good evening.